ఉన్నారా ఎవరైనా వాచింగ్ ఉన్నారా?
15 members. 15 members watching.
Yeah. Good morning, children. Watching unnara? Yeah. Very good morning, children. Hope everyone is doing great. We are just 1 week away from the NEET 2024. I think everyone is on the track, and nearly 8 grand tests. Good morning, children. You have written, and you might have gained a well experience. Good morning, children. Hope everyone is doing great. The final NEET. We are just 1 week still away from almost all the students need to improve exam everyone skills is on the track. So in the next 4 tests nearly you have 8 grand tests. Try for you have improving that examination. You might have gained a well experience. So with that definitely taking we will be getting still more marks. Still okay, almost now all the students. So this is the NEET refresher exam classes physics and chemistry. So in the next 4 tests which you have in the last class we have discussed chemical kinetics and part of the electrochemistry. So and now definitely electrochemistry will be continued more marks. Now children remember now Faraday's so first NEET refresher. There are so many problems in your materials, but all the problems related to Faraday's law can be solved with this statement, that is 1 Faraday will deposit gram equivalent weight of any substance. That means this one 2 Faradays 2 gram equivalents, and 1 Faraday will make 6.023 into 10 to the power of 23 electrons to migrate from one electrode to another electrode, and the same 1 Faraday will give 6.023 into 10 to the power of 23 by valency number of atoms either deposited or liberated. Suppose if it is a gas, 22.4 by valency of all atoms in liters will be released. Now let us take for example, I am taking 1 Faraday through sodium chloride aqueous solution. When sodium chloride aqueous solution is electrolyzed by using the platinum electrode, we will be getting hydrogen at cathode, chlorine at anode. Now here I said 1 Faraday. 1 Faraday will give gram equivalent weight of any substance, that is 1 gram, and here it is 35.5 grams. Suppose in the numerical, if ever they ask 0.1 Faraday, when 1 Faraday will give this much, 0.1 Faraday will give how much? Are the directly proportional. Is it clear? Then how many electrons are migrated? That means how many electrons are migrated? 6.023 into 10 to the power of 23 electrons are migrated from one electrode to another electrode. Clear? Then how many atoms are obtained? Now let us see hydrogen. 6.023 into 10 to the power of 23 by valency. What is the valency of hydrogen? It is 1. So this number of atoms of hydrogen, suppose if you want molecules, then as every hydrogen molecule has 2 atoms, then this by 2 will give the number of hydrogen molecules. And as hydrogen and chlorine both are have the same valency, then the same number of chlorine atoms and half of this number of chlorine molecules are obtained. Now suppose if you want the volume of hydrogen and chlorine liberated, now you see this is 22.4 by valency of all atoms in liters for 1 Faraday. Here I said 1 Faraday. So 22.4 by 2 hydrogen atoms are there in one molecule. So valency is 2, that is 11.2 liters at STP. And chlorine is also have the same valency, and chlorine is also same 11.2 liters of chlorine. Is it clear, children? So sometimes what will happen is they will ask in a reverse way. Reverse way means like 5.6 liters of hydrogen is obtained, liberated at cathode. What is the quantity of electrical charge passed? So that means 11.2 liters of hydrogen because of 1 Faraday. 5.6 liters of hydrogen is equal to how many Faradays? Is it clear, children? Yes. Then see any number, sometimes you may get a question like this. 2 Faradays of electrical charge with 50% efficiency, current efficiency is passed. Whenever they speak of current efficiency, you need to calculate actual number of, that means the number of Faradays passed, and that is equivalent to the number of Faradays with 100% efficiency. Then 2 Faradays with 50%, that is equal to 1 Faraday with 100% efficiency. Then 1 Faraday means based on this you can calculate. Sometimes you may get question like this: how many Faradays of electricity with 50% efficiency required to get 12 grams of magnesium? 12 grams of magnesium. First of all, you need to see what is the equivalent weight of magnesium. Equivalent weight of magnesium is how much? It is 12. How many grams of magnesium is obtained? 12 grams of magnesium. So 12 by 12, that is equal to 1 gram equivalent weight. For 1 gram equivalent weight, we require 1 Faraday. So here we require 1 Faraday. But what is the condition they said? The current which is available to us is 50% efficiency. Suppose if you use 1 Faraday, it is equivalent to 0.5 Faradays only. So as it is 50% efficiency, we require double the number of Faradays. That means 2 Faradays of electricity with 50% efficiency. If passed, we will get 12 grams of magnesium. Is it clear, children? Sometimes you may get a question like this, that is the cost of Faraday, the cost of electricity required to deposit some 40 grams of calcium is 100 rupees. Then how much would it cost to get 3 grams of hydrogen? Now you see, 40 grams of calcium we require rupees 100. So here we have to calculate cost of 1 Faraday. 40 grams of calcium is equal to 2 gram equivalents. 2 gram equivalents. 2 gram equivalents is equal to 2 Faradays. 2 Faradays costing how much? 100 rupees. So 1 Faraday cost how much? 50 rupees. 50 rupees. Is it clear? Then 3 grams of hydrogen. 3 grams of hydrogen is equal to 3 gram equivalents. So 3 gram equivalents require 3 Faradays. What is the cost of Faraday? It is 50 rupees. So 3 into 50, that is nothing but 150 rupees. Is it clear, children? See, based on this relation, you can solve any problem related to this Faraday's laws. Is it clear, children? Next. See, salt bridge which is used to connect the 2 electrodes in a galvanic cell or in an electrochemical cell, used to maintain electrical neutrality in both the electrolytes. If electrical neutrality is maintained, then electrons will move from one electrode to another electrode continuously, and that combination of electrodes will function as an electrochemical cell, and it is continuously generating electricity. Is it clear, children? Now, see, by using the Nernst equation, you can calculate single electrode potentials. Now, in the case of a metal reduction process means it is like this: M plus N electrons giving rise to N. This N is the number of electrons involved. Then E is nothing but reduction potential, and this is nothing but SRP, and this is nothing but concentration. This is the number of electrons involved. Now take for example, if ever I give the question like this: 0.1 molar zinc sulfate, means zinc rod is dipped in the 0.1 molar zinc sulfate solution and find its reduction potential. E naught value will be given to us, it is equal to minus 0.76 volts. Then here I am doing like this: E is equal to E naught, that is minus 0.76 plus 0.50591 by 2 log 10 to the power of minus 1. Log 10 to the power of minus 1 is equal to minus 1 here. So this into that is equal to then here it will be E is equal to minus a 0.76 minus a 0.06 I am writing 2. So, this is the value that decreases from 0.76. So, overall it becomes minus a 0.79 volts. Is it clear, children? Then, so in the case of metal electrodes and also hydrogen electrodes, reduction potential decreases on decreasing the concentration of an electrolyte. So, if 10 times of the concentration of an electrolyte is decreased, the decrease in the potential will be 0.06 by N volts. So, for every 10 times dilution or for every 10 times decrease in the concentration, a decrease in the potential of a metal electrode will be 0.06 by N volts. Is it clear, children? Then, when it takes non-metal electrode, in the case of non-metal electrode like a chlorine electrode, hydrogen electrode, bromine electrode, the reduction potential increases on decreasing the concentration. Now, because here it is a minus sign and here it, if you keep the 10 to the power of minus 1, it becomes a minus into minus it becomes a plus. Is it clear, children? Now, I am taking like this 0.1 molar Cl minus ion, means a platinum wire is dipped in a solution containing Cl minus ion and chlorine gas is circulated around that. Then find its EMF, its reaction potential. E is equal to plus 1.36, this is nothing but a reduction SRP of chlorine electrode minus 0.06 by 1, because valency of chlorine is that minus 1. So, this is the minus 1 into minus a plus, that is equal to plus 1.42 volts. Is it clear, children? That means for every 10 times decrease in the concentration of an electrolyte, reduction potential of metal electrode and hydrogen electrode decreases by 0.06 by N volts. Is it clear? Reduction potential of non-metal electrode increases by 0.06 by N volts. This N is the valency, that is the important thing. Is it clear, children? Then, now here you see 10 power minus 1 molar, 10 power minus 2 molar, 10 power minus 3 molar, 10 power minus 4 molar. Reduction potential of chlorine electrode is maximum with which of this concentration? Then just now only I told you that reduction potential of non-metal electrodes increases on decreasing the concentration. So, smaller the concentration, greater is the reduction potential. So, this one. Is it clear, children? Suppose if ever we ask with which of these concentrations reduction potential of zinc electrode is the maximum. In the case of zinc electrode, zinc is a metal electrode, reduction potential of metal electrodes is directly proportional, that means increases on increasing the concentration of electrolyte. That means here you see this is the 10 power minus 1, here I am writing like this, E naught is equal to E naught plus a 0.06 by 2 log 10 to the power of minus 1, here 10 to the power of minus 2, here 10 to the power of minus 3, here 10 to the power of minus 4. Then here this value is already minus a 0.76, then this becomes a minus. So, this will be minus a 0.79 volts, this will be minus a 0.82 volts. So, what will happen? Negative value goes on decreases. So, positively this value, that means with this concentration, reduction potential of zinc electrode is maximum. Is it clear, children? In the case of non-metal electrode, reduction concentration should be least to have the higher reduction potential. In the case of metal electrodes, concentration of an electrolyte should be least to have the higher reduction potential. Clear? Next, in the case of hydrogen, minus a 0.06 into pH. That means this is a reduction potential of hydrogen electrode with the given concentration. Is it clear, children? Then reduction potential of hydrogen electrode, this is the hydrogen electrode, this formula is applicable only for hydrogen electrode. Is it clear? Suppose if I say that electrolyte in which a platinum wire is dipped and around which hydrogen gas is circulated, the pH is changed from 0 to 7. 0 to 7. Then what is the change in the reduction potential? Then pH is equal to 0. That means E is equal to 0. Then pH is equal to 7 minus a 0.42 volts. So what will happen? Reduction potential of a hydrogen electrode changes from 0 to minus a 0.42 volts. Is it clear, children? Sometimes in the numericals, what will happen is they may ask oxidation potential of hydrogen electrode when the pH is equal to 3. Oxidation potential. Use the same formula but change the sign. That is minus a 0.06 into 3 is the reduction potential. Then oxidation potential is plus 0.06 into 3. Is it clear? Yes. Now, see, if ever we combine the two electrodes to make the cell, whenever two electrodes are combined to make the cell, the electrode with smaller reduction potential will act as an anode, electrode with higher reduction potential will act as a cathode. Now, take for example, zinc and copper electrode. It is a minus a 0.76 volts, it is a plus 0.34 volts. So, electrode with a smaller reduction potential will act as an anode. So, whose reduction potential is less? Zinc. So, zinc will act as an anode and copper will act as a cathode. Is it clear, children? Then, now if ever I connect zinc with standard hydrogen electrode, zinc with standard hydrogen electrode, standard hydrogen electrode will have the 0 potential and zinc will have the minus of 0.76 volts. There is no need for you to remember this value will be given, but you should know that zinc will have the negative reduction potential. Similarly, I am taking copper electrode and copper will have the positive reduction potential 0.34 volts. Now, if these two are combined to make the cell, then here zinc will act as an anode and this standard hydrogen electrode will act as a cathode. Yet anode oxidation, yet cathode reduction reaction takes place. Now, if ever we combine these two electrodes, that means standard hydrogen electrode and copper electrode. So, here standard hydrogen electrode will have the smaller reduction potential. So, this will act as an anode and this will act as a cathode. Is it clear, children? Then, now if ever we make the cell with this combinations, that means electrode with a smaller reduction potential as an anode and the electrode with higher reduction potential as a cathode, and that combination will generate current. And that means the EMF of the cell will be positive. If the EMF of the cell is a positive, reactions are spontaneous. Electrons flow will take place continuously and that combination will generate the current. Is it clear, children? Then, so EMF of the cell is equal to E cathode minus E anode. Now, take for example this one. So, children, these are the very simple problems. This is anode, this is the cathode. Then E cathode minus E anode. What is the cathode here? It is a plus of copper electrode plus 0.34 minus of minus 76. This is equal to plus 1.1 volts. Now, what is this 1.1 volts? It is the EMF of the cell, EMF of the cell. Then sometimes they may ask a delta G naught value, means a standard free energy change for the galvanic cell involving zinc and copper electrode. Then delta G naught is equal to minus NF E naught. Then what is N? Number of electrons transferred. How many electrons are transferred in the case of this zinc and copper? 2 electrons. So, this is equal to minus 2 into Faraday is 96,500, then E naught, that is equal to 1.1 volts. This is nothing but standard free energy change. Is it clear? Sometimes standard free energy change will be given and they may ask us to calculate standard EMF of the cell. That can also be calculated. Then sometimes what will happen is they will give a few electrodes. They may ask which of these 2 electrodes will be combined to get a cell with maximum EMF. So, now listen carefully. Yes, see, E cell is equal to E cathode minus E anode. in order to have the maximum E cell value, E cathode, that means a cathodic electrode should have more positive reduction potential and anodic electrode should have more negative reduction potential. So, among the electrodes that are given, the electrode with a more positive reduction potential need to be taken as a cathode and the electrode with a more negative reduction potential need to be taken as an anode. In that combination will give the cell with the maximum EMF. Is it clear, children? Then here you see, to get the cell with the maximum EMF, anodic electrode should have a greater negative reduction potential and a cathodic electrode should have greater positive reduction potential. Is it clear? Then now see, if ever we see the EMF of the Daniell cell, that means the combination of zinc and copper electrode. Now this is the formula. This is the formula. If ever we take Cu plus 2 and zinc plus 2 at 1 molar concentration, that means a standard, then E cell becomes a E0 cell. Suppose if you change the concentrations, like they will say like this, 0.1 molar CuSO4 and 0.1 molar ZnSO4 and find EMF of the cell. Now here you see, this is made 0.1, this is made 0.1. So, log 0.1 by 0.1 is equal to 0. So, then E is equal to E0 cell. Is it clear, children? Then that means if the concentrations of cupric and zinc ions are changed to the same extent, then that value remain the same. Sometimes what will happen is this cupric ion concentration is made 0.1 molar and zinc ion concentration is made 0.01 molar. 0.01 molar. 0.1 by 0.01, it is nothing but log 10. Log 10 is equal to 1, then this is equal to E0 cell plus a 0.0591 by 2, because 2 is the number of electrons transferred from zinc electrode to copper electrode. Is it clear? Then in order to increase the EMF of the Daniell cell, or in order to increase the EMF of the cell which is made with 2 metal electrodes, then concentration of the cupric electrode, that means the cathodic electrolyte, should be increased and the concentration of anodic electrolyte should be decreased. If we can do that, then we can increase the EMF of the cell. Now, if you take the Daniell cell, in the case of Daniell cell, increasing the concentration of cupric sulfate, because the cupric sulfate is the cathodic electrolyte, zinc sulfate is the anodic electrolyte. So, in general, when a cell is made with 2 metal electrodes, we can increase the EMF of the cell by increasing the concentration of cathodic electrolyte and by decreasing the concentration of anodic electrolyte. Is it clear? Then electrochemical series. Electrochemical series is the series in which different electrodes are arranged in the increasing order of their standard reduction potential. So, in that electrochemical series, at the initially we will have the lithium and at the bottom we have the fluorine. So, lithium has a more negative reduction potential and fluorine has more positive reduction potential. Is it clear? Then see, in the electrochemical series or in general, as the SRP value increases, then the tendency to act as a reducing agent decreases and the tendency to act as an oxidizing agent increases. So, strongest oxidant in aqueous solution is fluorine and the strongest reductant in aqueous solution is lithium because of the least SRP value. Is it clear? Suppose if ever I mention like this, zinc, some magnesium, copper, silver. Zinc, magnesium, copper, silver. Here magnesium and zinc will have the negative reduction potential, copper and silver have positive reduction potential. Is it clear? Among the magnesium and zinc, as the magnesium belongs to S block, its reduction potential is a more negative. So, among the copper and silver, copper has a more, this silver has a more positive reduction potential. So, among all these, the strongest reductant is magnesium and the weakest reductant is the silver, because in the electrochemical series, That means in that order, as the reduction potential value of an electrode increases, its tendency to act as a reducing agent decreases, and tendency to act as an oxidizing agent increases. That means the top one will reduce the bottom one, and bottom one will oxidize the top one. Is it clear? Then metals with negative standard reduction potential value, that means those are placed above the hydrogen in electrochemical cell, electrochemical series will displace the hydrogen. And the metals that are placed below the hydrogen in electrochemical series, that means those who have the positive reduction potential, they cannot displace hydrogen from acids. Is it clear, children? Then now take for example, I am taking copper sulphate, and this copper sulphate I am storing in a container made with zinc electrode, let us assume, okay, made with zinc metal. So, is it possible to store cupric sulphate in the zinc? No, it is not possible, because zinc is a stronger reducing agent than the copper. So, what the zinc will do is, zinc will reduce cupric ions to copper and get oxidized to zinc. So, copper sulphate cannot be stored in the zinc container. Instead, zinc sulphate can be stored in the copper container. That means for storing a salt solution, a metal container with a smaller SRP cannot be used, but a metal container with a higher SRP can be used. This is the very important thing, children. Now, take for example, cupric sulphate. Cupric sulphate can be stored in the silver container, because silver will have the plus 0.8 volts reduction potential, copper has a plus 0.34 volts reduction potential, and zinc has a minus 0.76 volts reduction potential. So, copper sulphate cannot be stored in the zinc container, but can be stored in the silver container. Is it clear? Then now, if ever you take the concentration cell means the cells in which the electrolyte of both anode and cathode are same. So, they are the concentration cells. So, if ever anodic will have the concentration C1, cathodic electrolyte will have the concentration C2, then this is the EMF of the cell by which we can calculate. Then similarly, if you take the gas, that means gaseous electrodes. So, for gaseous electrodes generally concentration we measure in terms of the pressure, that is a P1 and P2. Then now here you see children, let us discuss one important question here. What is the pressure of a hydrogen electrode required to be applied to get reduction potential of a hydrogen electrode is 0. Reduction potential of hydrogen electrode is 0. Now, you see children, see this they are asking, what they are asking, this 0, and this is anyhow 0. But that a platinum wire of the hydrogen electrode is placed in the normal pure water. So, normal pure water means pH is equal to 7. That means H plus is equal to 10 to the power of minus 7. So, what is the pressure of hydrogen required? Pressure of hydrogen required to get reduction potential of hydrogen electrode as 0 when it is placed in the pure water. Now, you see, this we know standard reduction potential hydrogen electrode reduction potential is 0, and this should be 0. Then if this is 0, this is 0, then what will happen is this becomes 0. If that becomes a 0, then log H plus square by pressure of hydrogen electrode is equal to 0. Is it clear? Then if you take anti-logarithms of both sides, H plus square by pressure of hydrogen is equal to 10 to the power of 0, that is equal to 1. Then H plus square is equal to pressure of hydrogen electrode. That platinum wire, where it is kept? It is kept in the water. That means where the pH is equal to 7, H plus is equal to 10 to the power of minus 7, then 10 to the power of minus 7 whole square, that is the pressure of hydrogen electrode. So, if ever we apply 10 to the power of minus 4 atmospheric pressure on that platinum wire which is kept in the pure water, then reduction potential of hydrogen electrode becomes 0. Is it clear, children? Then now, in the case of lead storage battery, when the lead storage battery is discharged. Discharge means it is working. So, when it is working, sulfuric acid will be consumed. So, during the charging of the lead storage battery, charging means reverse, say discharging means working. So, charging means we are charging it for further use. So, during the discharging, sulfuric acid will be consumed and concentration of electrolyte, that means sulfuric acid, will be decreased, density also decreases. Then during the charging, so we need to generate sulfuric acid. So, sulfuric acid formation takes place, its density also increases. Now, this is the reaction taking place during the discharge. A reverse reaction takes place during the charging. Is it clear? Then, in the case of lead storage battery, equivalent weight of sulfuric acid will be 98/1. Normally, equivalent weight of sulfuric acid in the general case is 98/2. It is a dibasic. So, here it is 98/1. Now, children, this is the very important thermodynamic efficiency of the fuel cell. Thermodynamic efficiency of the fuel cell. Now, this delta G is equal to minus NFE by delta H. Delta H value will be given in the problem. So, they may say that it is minus X and E cell will be given. Then once they mention the E cell, and they will also mention the number of electrons involved. So, once they say number of electrons involved, that you have to substitute, and F is equal to 96,500 and E cell will be given, and this is the delta H. So, thermodynamic efficiency of the fuel cell is equal to delta G by delta H. This is the very important. Is it clear, children? Yes. అయిపోయిందా 840 okay మరి 840 okay children, so we have discussed the important points of this electrochemistry. Now let us discuss the solutions. See, solutions is also very important chapter, and from the solutions you may get 2 questions, and mostly one question is from pre-colligative properties and one question is from colligative properties. Now, let us see in many of the previous examinations they asked question related to just a simple molarity. See, generally they do not ask so complicated questions. Out of the 50 questions in the chemistry, at the most you may get one very tough question, and all the remaining 49 are the normal and moderate questions. From that you need to solve only 45 questions, remember. Then, so molarity is equal to, that you know pretty well. Sometimes you may get question like this, 6% urea solution, find the molarity. If they do not mention percentage by weight or percentage by volume, we need to take it as weight by volume. If they say percentage by weight, we need to take a W by W, weight by weight. Then 6% urea, that is 6 into 10 by molecular weight of urea is 60, that is nothing but 1 molar. Sometimes what will happen is they will give like this, 98% by weight sulfuric acid of the density 1.2 grams per cc. Find the molarity. So, here you see 10 into weight percent, how much? 98 into density 1.2. What is the molecular weight? 98. Then that becomes 12 molar. Is it clear, children? Sometimes you may get question like this, what volume of this solution is required to prepare 100 milliliters of 1 molar sulfuric acid solution. What volume of this is required to prepare 100 milliliters of 1 molar sulfuric acid solution? So, first of all you have to calculate molarity, 12 molar, and what volume of this is required, that means M1V1 is equal to M2V2. What is M2 here? 1 molar. What is V2 here? 100 milliliters. And what is M1 we got? 12. Then what is V1? That can be calculated. Sometimes you may get question like this. 1 milliliter of this solution is diluted to 10 milliliters. What is the molarity of diluted solution? First of all, calculate molarity of the concentrated solution. What is the molarity of concentrated solution? 12 molar. Then what are we doing? 1 milliliter is diluted to 10 milliliters. That means the solution is diluted to 10 times. Concentration decreases by 10 times. So, that is 12 by 10, that is 1.2 molar. But children, remember, read the questions properly, you will get solutions with 100% correct answers if you read the question properly. And normality, molarity, same formulas, there is no difference. The only difference is wherever there is a molecular weight, replace it with equivalent weight. Then molality. The difference between the molality and molarity, in the case of molarity is volume of solution in milliliters we use, here weight of the solvent in grams we use. So, that is the reason molarity, normality depends on the temperature, and molality and mole fraction are independent on the temperature. Means when there is no volume term in the formula, it is depends independent on the temperature. When there is a volume term, depends on the temperature. Now, there is a slight difference between the molality and mole fraction, though both are independent on the temperature. That is, molality has units, moles per kilogram of the solvent. Mole fraction has no units. You may get question like this. Which of the following method of expressing the concentration has units but independent on the temperature? So, has units and independent on the temperature, that is the molality, and has no units and independent on the temperature, that is nothing but mole fraction. Is it clear? Now, sometimes now this is the very important formula. This is a very important formula. Sometimes you may get a question like this. Mole fraction of solute in the water is 0.2. Children, remember, mole fraction of a solute is 0.2. It means that 0.2 moles of solute are present in 1 mole solution, 1 mole solution. So, mole fraction of solute is 0.2 and mole fraction of solvent is how much? 0.8. Then by giving the mole fraction of a solute in aqueous solution, they are asking the molality. Now, you see molality. Molality is equal to number of moles of the solute. What is the number of moles of the solute? Mole fraction 0.2 divided by weight of solvent in kilograms. So, weight of the solvent means what is the mole fraction of solvent? 0.8. So, that is equal to 0.8 moles. So, 0.8. This is the number of moles. But what I want? I want weight of the solvent in kilograms. So, I am multiplying this with 18. So, what I will get here? Here I will get weight of the solvent in grams, but I want it in kilograms. So, by 1000. So, this is equal to 0.2 into 1000 by 0.8 into 18. Is it clear, children? This is the very important. So many times this question is asked, and the same question may be asked like this. Relative lowering of vapor pressure of a solution is 0.2. Find the molality. Relative lowering of vapor pressure of a solution is equal to mole fraction of the solute. Again the same thing, it is a 0.2. So, 0.2 means 0.2 moles of solute are present in 1 mole solution. So, solution means their solute and solvent only. Is it clear? No, by using this formula or by using the general definition of molality, you can do it. But the important thing, children, see, generally solvent is water, but solvent need not be water. Solvent can be a benzene. Suppose here if they say that mole fraction of a solute in a solution containing benzene as a solvent is 0.2, then find molality. Now, here you see 0.2 divided by 0.8 into 78 because molecular weight of benzene is 78 divided by 1000. So, again the most important thing is reading the question, underlining the keywords, underlining the keyword. In the previous case water, in the present case it is the benzene. So, relevant molecular weight you need to substitute. Is it clear, children? Then mole fraction of the solute is equal to molality by molality plus 55.5. Again this 55.5 is equal to 1000 by 18. That means by considering water as a solvent. Suppose if they say that benzene as a solvent, then 1000 by 78 and basing on that you need to substitute. Is it clear, children? Now, vapor pressure of a solution of two liquids you can calculate by using this formula. P naught A XA plus P naught B XB. What is the P naught A? That is the vapor pressure of pure component A, and this is the mole fraction of A. This is the vapor pressure of pure component B. This is the mole fraction of B. And the relative lowering of vapor pressure is equal to P naught minus P by P naught. And this is equal to mole fraction of solute. Just now only we have discussed it, and this can be converted into molality. And once you know the molality, you can calculate a mole fraction of either solute or solvent. Mole fraction of solute is directly equal to relative lowering of vapor pressure. Then, now mole fraction of A, that means a component in the vapor phase, this is the very important. That is that we indicate with Ya. Ya is equal to Pa by P total, that is Ya is equal to P naught A XA by P naught A XA plus P naught B XB. This is nothing but a mole fraction, that means a mole fraction of a component in the vapor phase. Whenever they ask in the vapor phase, you need to do it like this. Similarly, mole fraction of a component B in the vapor phase is equal to PV by P total. And this P naught A XA plus P naught B XB, that means it is the Raoult's vapor pressure or theoretical vapor pressure of the solution containing two volatile components. Is it clear, children? Next, if you take the ideal solutions, for that ideal solutions, delta V mixing is equal to 0. That means the ideal solutions are formed neither with a volume change nor with a heat change. Means if you take 60 milliliters of A, 40 milliliters of B, you will be getting 100 milliliters of the mixture of A and B. And similarly, delta H mixing is 0. Delta G is negative. That means delta G is negative means spontaneous. That process is taking place by itself. And delta S is a positive. That means entropy change is increasing. Spontaneous processes are accompanied by decrease in the free energy and increase in the entropy. Next, non-ideal solutions. Non-ideal solutions do not obey Raoult's law. And for non-ideal solutions, delta V is not equal to 0. And delta H is not equal to 0. That means the solutions which are formed with volume change or with heat change are called non-ideal solutions. Even for ideal solutions and non-ideal solutions, delta G is negative and delta S is positive. Next, if you take the positive deviation, see, children, remember positive deviation means the vapor pressure of the solution is greater than the Raoult's vapor pressure or greater than the theoretical vapor pressure. This is called Raoult's vapor pressure or this is called theoretical vapor pressure, and this is the observed vapor pressure, that means experimental. If the experimental vapor pressure is greater than the Raoult's vapor pressure, that solution will show positive deviation. When the experimental vapor pressure is greater than the Raoult's vapor pressure, it means if the molecular attractions decreases, vapor pressure increases. Clear? Now here you see, delta V mixing is a positive. Delta V mixing is a positive means this kind of solutions are formed with increase in volume. That is, if 40 milliliters of A plus 60 milliliters of B are mixed, if you get 101 milliliters of A and B, so 101 minus 100, that is equal to 1 milliliter. So delta V is a positive, and delta H, that means a heat change, it is an endothermic process. Now here you see, as the experimental vapor pressure is more, its boiling point is less. So, these are called minimum boiling azeotropic mixtures. If you take the negative deviation means delta V is a negative, delta H is a negative, that means exothermic, and experimental vapor pressure is less than Raoult's vapor pressure. So, Raoult's vapor pressure or theoretical vapor pressure, as the experimental vapor pressure is less, that means actual vapor pressure is less, their boiling points are more. If the boiling points are more, they are called maximum boiling azeotropic mixtures. Is it clear, children? This will be continued in the next class. Thank you.
Scientists, they are assuming what radius of the nucleus is what spherical, but any spherical radius, this radius is r proportional to a power 1 by 3, where a is what mass number. Any nucleus ZXA we are writing, where Z is number of protons, A is what mass number of neutrons is what A minus Z. If suppose alpha particle, that is 2He4, how many protons, how many neutrons means what? 2 protons and 2 neutrons, 4 minus 2, r proportional to a power 1 by 3, that is second. Surface area of the nucleus, surface area proportional to r square, that is a power what 2 by 3, but volume of the nucleus is proportional to r cube, but r cube can be written as what? A. If the question is there is a uranium nucleus, its mass number is what? A, then volume of the nucleus proportional to yellow, sir. Volume of the nucleus proportional to A, where A is what? Mass number. But density of the nucleus, density can be written as mass by volume, but volume of the nucleus is what? A. A and A goes cancel. Density does not depend on mass number. But based on this, a simple graphical question, that question is radius of the nucleus versus mass number graph, and surface area, that is a surface area versus mass number, that is also what? This graph, that is also this way graph is there. But density of the nucleus versus mass number, it does not depend on this, but density of the nucleus versus distance from center, distance from center. Distance from center means what? Nuclear density is what? Maximum at center, from nuclear density what? Gradually decrease and finally becomes what? 0. Careful about this graph and this graph. This graph is what? NCRT graph, that is density of the nucleus versus distance from center of the nucleus graph is this. But where the nuclear density maximum means what? At center. But density of the nucleus versus what? Mass number is what? Graph this. For any nuclear matter, density is equal to 1.2 or 1.4. But power important, 10 power 17 kg per meter cube. But condition, density of nuclear matter everywhere is what? Same. 2 nuclei given, that is what? Mass numbers given. What the ratio of density is asked? Just what? 1:1, right? And second is one important formula, that is Einstein energy equation, that is E is equal to delta m into c square. How to use this equation? Now I will discuss this. Sir, pen outlay. Right. Second equation is E is equal to delta m into c square. In any nuclear reaction, mass alone is not conserved. Mass and energy combinedly conserved. E is equal to delta m into c square. A simple question, suppose 2 grams of hydrogen converted into 1.98 grams of what? Helium. What is energy released asked? Actual mass is 2 grams, but final mass is what? 1.98 grams. That is E is equal to 0.02 into 10 power minus 3. Why 10 power minus 3 means what? Grams into 9 into 10 power what? 16, that is joules. But most of the nuclear physics problems, they are expressed in terms of what? Million electron volts. But electron volt is the unit of energy, 1.6 into 10 power minus 19 joules, but 1 joule is equal to 1 by 1.6 into 10 power what? Minus 19 electron volts. And other unit is what? Kilowatt hour, that is 36 into 10 power what? 5 joules, right? This way we can write. And second question, or suppose in a nuclear reaction, that is 1 gram of what? 92 uranium 235 used, but 0.1 percentage of mass can be converted into energy. What is the energy release entered? E is equal to total mass is what? 1, but out of that 0.1%, 1 into 0.1 by 100, but gram is what again? 10 power minus 3 into 9 into 10 power what? 16. And otherwise, if they will give 1 microgram is completely annihilated, completely annihilated means what? This mass completely converted into energy. Then E is equal to delta M. Microgram, that is what students are generally they are using what? 10 power minus 6, but 10 power minus 6 grams into 10 power what? Minus 3. Why minus 3 means what? Micro is what? 10 power minus 6, gram is what? 10 power minus 3 into 9 into 10 power what? 16, that is in what? Joules. And here conversion factors and caring about the problem, conversion factors. And next point is 1 AMU, 1 atomic mass unit, 1 AMU atomic mass unit is equal to 1 by 12th part of what? 6C12, that is equal to mass of the proton, approximately mass of the proton is 1.6 into 10 power minus 27 kg, that is 1 AMU. But 1 AMU is equal to that 1 AMU, 1 atomic mass unit is what? Annihilated. How much amount of energy released? What? 1 atomic mass unit is equal to 931.5 MeV by C square. What is this physical meaning? 1 atomic mass unit destroys, how much amount of energy released? What? 931.5 million electron volts energy released. 1 AMU is equal to 931.5 is wrong. Why? Because this is mass, that is energy. 1 AMU is equal to 931.5 MeV by what? C square. Physical meaning is 1 AMU annihilated, what energy released? 931.5 MeV. Or based on this, 1 proton annihilated, what energy released? What? 931.5 MeV. But based on this, 1 alpha particle is there, 2He4 is what? Completely annihilated. What is the energy released? That is what? 4 AMU. 4 AMU, 1 AMU already energy is what? 931, 4 into 931.5 million electron volts energy released. Or if a condition 1 deuterium and 1 alpha particle both are completely annihilated, what is the energy released asked? That is what? 2 AMU, that is 4 AMU, 2 plus 4 is what? 6, 6 into 931.5 MeV. And how to use this? E is equal to delta M into C square. Now clarity is there. And second, mass defect and binding energy, important term. What is mass defect means what? Any nucleus, that is what? Suppose ZXA, that is mass of the nucleus is what? Mn. Mass defect in case of nuclear physics, mass defect is what? The difference between the what? Nucleon's mass and formed nucleus is called mass defect. But what is nucleon's mass means what? Mass of the proton into how many protons are there means what? Z into MP plus A minus Z number of neutrons into mass of each neutron minus mass of the what? Nucleus. That is what? Mass defect. Mass defect. But once mass defect is there, this mass defect always measured in AMU, atomic mass unit. But once mass defect is there means what? Nucleon's mass is always greater than what? Nucleus mass. Nucleon's mass is always greater than what? Nucleus mass. But nucleons, this is nucleons, that is what? Nucleus. This is what? Nucleons are combined to form heavy nucleus. Right? Nucleons are combined to form nucleus. But this mass is what? More. There is a difference. But where that mass gone means what? That mass can be converted into what? Energy. That is the reason mass alone is not conserved, energy alone is not conserved, mass and energy combinedly conserved. Now, that energy is called what? Binding energy. what is binding energy? By definition, by mathematical formula, binding energy is equal to delta m into c square. This delta m is what? AMU. Now, which is equal to what? We can write delta m in AMU multiplied with what? 931.5 MeV. Direct question. Sometimes in a nuclear reaction, mass defect is equal to what? 0.7 AMU. What a binding energy asked? Binding energy is equal to 0.7 into 931.5. But by definition, energy released or energy absorbed means what? If you take, this is nucleons, it is formed a nucleus. Nucleon's mass is what? More. That is what? This is what? More mass, but this is less mass. More mass can be converted into less mass. There is a disappear mass. The disappear mass converted into what? Energy. But energy released or energy absorbed means what? Energy is what? Released. That energy released is called what? Binding energy. That is when nucleons are combined to form a nucleus, energy is what? Released. That energy is called what? Binding energy. That binding energy is what? Delta M in unit. But reverse. This is nucleus is nothing but what? Heavy nucleus splits into nucleons. Less mass can be converted into what? More mass. How it is possible means what? You are supplying some energy. The energy absorbed. That energy absorbed is called what? Binding energy. Binding energy definitions is what? When energy released, nucleons are combined to form a nucleus, or energy absorbed when nucleus splits into what? Fragments. That energy is called what? Binding energy. That is what? Delta M in AMU into what? 931.5 AMU. But binding energy, when binding energy is what? More. That is what? That nucleus binding energy is what? More. We cannot decide the nucleus is what? More stable or less stable. That is stability of the nucleus decided by what? It's not binding energy, but which term means what? Binding energy per nucleon. Binding energy per nucleon. Binding energy by mass number gives stability of the nucleus. If the binding energy per nucleon is what? More, that nucleus is what? More stable. Binding energy per nucleon is what? Less, that is what? Nucleus is what? Less stable. They will give, that is what? 1H2 and 2He4 and suppose 5C12. Binding energies they will give. Which is more stable asked? Binding energy. Is binding energy suppose is 4.2 given. That binding energy is what? 5.2 given. That is 5.4 given. Calculate 4.2 by 2, 5.2 by 4, 5.4 by 12. If which is more value, that is what? More stable. But out of that 4 options, if Fe56 is there, no need to check. Your answer is what? Fe56. Why Fe56 means what? Binding energy per nucleon for elements. This is binding energy per nucleon versus mass number. The graph is what? This way we are noticing. As mass number increase, as A increase, binding energy per nucleon also increase, reaches maximum value, but that value is equal to what? That is Fe56. Binding energy per nucleon is what? More. In the periodic table what? That is what? More stable. From that onwards, as mass number increase, binding energy per nucleon, that is decrease. That is a theory question also we can expect. Which of the following element is what? More stable? Fe56, right? Fe56 is not there. 3 elements given. Which is more stable means what? Binding energy per nucleon calculate. Binding energy per nucleon is what? More means what? That is what? More stable. Binding energy per nucleon, average binding energy or binding fraction, all are what? Same. But which of the following is what? Correct about what? Binding energy per nucleon with mass number means what? As mass number increase, binding energy per nucleon increase and reaches max value. From that onwards, as mass number increase, binding energy per nucleon is what? Decrease. Right. This is one important information about what? But very careful. Here some students are what? Doing what? Mistake. Why they are doing mistake means what? By reading what? Chemistry, exothermic, endothermics, what? They are committing mistakes. But we are doing what? Physics. That is A plus B is equal to C plus D. This is called reactants. That is reactants. That is products. This is binding energy of the reactants. That is binding energy of what? Products. It's not energy, binding energy of reactants, binding energy of what? Products. Then if condition 1, binding energy of products is greater than binding energy of what? Reactants. that is binding energy of what reactants and binding energy of products. Binding energy of products is greater than binding energy of what reactants, then energy is released. Energy is released. But how much amount of energy released? Difference, that is binding energy of the products minus binding energy of what reactants. And if binding energy of what reactants is greater than binding energy of what products, then energy is what absorbed. But how much amount of energy? Energy is what absorbed. How much amount of energy absorbed means what? That is binding energy of what reactants minus binding energy of what products. Most important, it's a very important expression. Products and reactants. Which side products means what? That side is products, that side reactants. If binding energy of the products is greater than binding energy of the reactants, energy is what released. How much amount of energy released? Binding of the products minus binding of the reactants. If binding energy of reactants is greater than binding of the products, then energy absorbed. How much amount of energy absorbed? Binding energy of the what reactants minus binding of the what products. Here question is, they will give in the reaction, following reaction, they will give one reaction, that is what 1H2 plus 1H2, that is equal to 2He4 plus others. They will give this way one equation they will give. The given equation correct or not, you want to check means what? That is 1 plus 1 2, that is also 2, 2 plus 2 4, that is also 4. They will give condition is what? Binding energy per nucleon of 1H2 is 2.5 MeV and binding energy per nucleon of 2He4, that is what? 3.2 MeV. Then which of the following is correct entered? What I am doing is, this is reactants. Binding energy per nucleon of 1H2 is 2.5, that is we can write what? 2.5 is equal to binding energy by its mass number is what? 2, that is binding energy is what? 5. This is 5, that is also what? 5, but binding energy per nucleon, that is 3.2, that is 4 into 3.2. 5 plus 5 is what? 10. 4 into 3.2, that is 12.8, 12.8. That is 10, that is 12.8. Which is more energy? Right side more energy. Right side is what? Products, right? Energy. Binding of the products is what? More energy released. How much amount of energy released? Energy released is equal to 12.8 minus 10, which is equal to what? 2.8 MeV. This way we can write. Most important expression. I am expecting this question. Last year asked question. Again we are expecting the question from binding energy, right? And once that is there, and nuclear fission and nuclear fusion differences. You want to read what? Nuclear fission, FISSION, nuclear fission, and FUSSION, nuclear fission, and nuclear reactor. Nuclear reactor. Here also we are expecting one question. Nuclear fission. What is nuclear fission means what? One heavy nucleus 92 NEM what? 235 bombarded with what? Neutron. That is what? Projectile. Projectile is neutron, but best projectile is what? Neutron. And this can split into two fission fragments, barium and what? Krypton. But need not be barium and krypton, can be anything, but plus, that is what? That is 3 into 0 N1 plus 200 MeV, right? Now listen, one reaction they will give, right? This is what? Nuclear fission. Heavy nucleus splits into what? Fragments. With fission fragments, how many neutrons are released? 3 neutrons are released. How much amount of energy released? 200 MeV electron volts energy is what? Released. What is understanding? One atom undergoes one fission, one atom undergoes one fission, 200 million electron volts energy released. 200 million electron volts are right? 235 grams of 92 uranium 235 contains 6 into 10 power 23 atoms, that is 1 gram of uranium contains 6 into 10 power what 23 by 235 number of atoms. That is, for 1 gram of uranium 92 uranium, what is energy released means what 6 into 10 power 23 into 235 into 200 MeV, but finally this value 8.202 into 10 power 10 joules. A standard conversion factor. Always doing this kind of calculation we cannot do in the examination hall. And a standard things, nuclear physics, modern physics, standard conversions are there. Compulsory you want to remember. What is standard conversion? Now listen. If 92 uranium 235 used as a nuclear fuel, 200 million electron volts energy is what released, that is 1 gram of uranium used in the nuclear fuel, energy released 8.202 into 10 power 10 joules. 1 joule, what is the amount of energy? 1 by 8.202 into 10 power 10 grams, that is one conversion. How they will give the question? 92 uranium 235 used as a nuclear fuel in a nuclear fission, 200 million electron volts energy is what released, that is 5 grams of what 92 uranium 235 used. What is the amount of energy released? They will ask. 1 gram 8.202 into 10 power 10. For 5 grams 5 into 8.202 into 10 power 10 joules. Or if condition in recent war between what, that is Russia and what Ukraine, but Russia people they are using 92 uranium 235 used as a nuclear fuel, 200 million electron volts energy is what released, but total amount of energy released is what 64 into 10 power what 6 joules. How much amount of uranium used? For 1 joule this, but 64 into 10 power 6 joules by 8.2 into 10 power what 10, that is in what grams. This is approximately 8, that is what close to 8, that is what 10 power 6 by 10 power 10, which is equal to what 8 into 10 power, that is what minus, that is 4, that is in what grams, right. This is close to 7.9 into 10 power what minus 4. We can write what 79 into 10 power minus 3. Minus 3 is what milli, that is options 79 milligrams, 100 milligrams, 1 microgram or 1 kg means what, that is 79 what milligrams. A standard conversion, a standard conversion. Why? Because this kind of questions are what, when you are entering into what last questions is nuclear physics, so Bohr's model, photoelectric effect, this only. But last moment there is no time, or your intention, definitely you can to handle the questions is what this way, with doing what fast calculation. If suppose other elements are given, one more standard conversion is right. Power, that is what power of the nuclear reactor can be written as N by T. What is N by T means what? Number of fissions per second, number of atoms undergoes what per fission into energy released in each fission or fusion. That is the power of the nuclear reactor, right. But if I am using A is what mass number of the element, A is what mass number, X grams of that sample is what used, but N is Avogadro number, N is what Avogadro number, then A grams of that sample contains, A grams of that sample contains N atoms. 1 gram of that sample contains what? N by A. But X grams of that sample contains what? N by A into X, this number of atoms. Now we can write what? Power is equal to X into N by A into T into energy released in each fission. But here X must be in grams. Why? Because A, but condition is given this mass number of the element is what? A, x grams of that element is used, n is Avogadro number, what a power of the nuclear reactor? X into n by At into what? This n by T is the number of fissions per second, but again one more standard conversion is there, that is 92 uranium 235 used as a nuclear fuel, right? 200 million electron volts energy is what released. Then to produce 1 watt power, how many number of fissions per second means what? 3.125 into 10 power 10 fissions per second. That is also a standard conversion, right? But condition 92 uranium 235 used as a nuclear fuel, 200 million electron volts energy is what released to produce what? 1 megawatt power. How many number of fissions per second? 1 megawatt. 1 watt is 3.125 into 10 power 10. 1 megawatt means what? 10 power 6. Answer is 3.125 into 10 power what? 10 into 10 power 6, 10 power 16. That 3.125 into 10 power what? 16 what? Fissions per second. But same question. 92 235 used as a nuclear fuel, 200 million electron volts energy is what released to produce how many number of fissions per minute asked? Per minute 3.125 into 10 power 10 fissions per second. Per minute means what? In 1 minute how many seconds are? 60 seconds. That is answer is 3.125 into 10 power 10 into 60, not divided by 60, into 60. Why? Because this is per second. Per second 3.125 into 10 power 10 fissions per second. Per minute means what? 3.125 into 10 power 10 into 60. This 2 are what? Standard conversion. Definitely it will help what? A great help in the examination hall. It's a right. Now listen. Power of the nuclear reactor is completed, right? And nuclear fission and nuclear fission and nuclear fission go for what? What is the just differences? Nuclear fission takes place all conditions, normal conditions also nuclear fission takes place, normal temperature, normal density that, but nuclear fission takes place only at high temperature, that is high temperature and high density. This state is called what? Plasma state. That state is called what? Plasma state. But where is the plasma state available? On surface of the what? Sun. That is, which of the following reaction can takes place on surface of the sun means what? It's a nuclear fission at high temperatures. But why high temperature? Nuclear fission takes place. Why? Because what is nuclear fission means what? 2 nuclei. That is what? 2 lighter nuclei. This is deuterium, that is also deuterium. These 2 lighter nuclei are combined to form heavier nuclear, that is what? Nuclear fission. But between deuterium and deuterium, both are positive charge. Electrostatic repulsion is there. This is electrostatic repulsion. But electrostatic repulsion, they are moving away from each other, but they want to combine. They want to what? Collide. Immediately, I am creating at high temperature. Because of high temperature, almost what? 10 power what? 7 Kelvin. At high temperature, this deuterium acts as like a gas molecule. Because of that temperature, it acquires what? Kinetic energy. That kinetic energy is what? Enough to overcome Coulomb repulsion. That kinetic energy is what? Enough to overcome what? Coulomb repulsion. Condition, nuclear fission takes place at high temperature, that is due to at high temperature splits into fragments are enough to overcome what? Coulomb repulsion. What? At high temperature kinetic energy is enough to overcome what? Coulomb repulsion. But nuclear fission 0.1% of mass can be converted into energy, but in nuclear fission 0.7% of mass can be converted into what? Energy. Nuclear fission takes place all conditions, but nuclear fission takes place only at what? High temperature. But here energy released is 200 million electron volts energy, with fission fragments what? 3 neutrons are released. But here that is energy released approximately 23.2 MeV, but with the fission fragments 2 positrons are released. 2 positrons are what? Released. But out of this, this is important. In nuclear fission, how much mass can be converted to energy means what? 0.1%. Nuclear fission, how much mass can be converted to energy means what? 0.7% of mass. And for nuclear reactor, K means what? Multiplication factor. What is K for what? Nuclear reactor. K is what? Multiplication factor. K is what 1 for a nuclear reactor. Nuclear reactor multiplication factor is equal to 1 or greater than 1 or less than 1 or not defined means what? K is equal to 1. And nuclear reactor, just read that what is the prompt neutrons, what is delayed neutrons, what is a moderators, what is control rates. Anyhow, IP you are reading essay question, nuclear reactor. Again, same concentrate. Why? Because theory question also we can expect. In the nuclear physics, what? This is what more than sufficient. And remaining is semiconductors. Semiconductors part is, right, main area semiconductors. Definition questions, intrinsic semiconductors, extrinsic semiconductors, N-type semiconductor and P-type semiconductor, and what are charge carriers, any semiconductors, alpha value, temperature coefficient of resistance, what, negative, this kind of questions. In semiconductors, what you want to cover? Just PN junction diode, read everything. And second one is what? Zener diode. Zener diode operate in the what? Reverse bias condition. And third part is what? Solar cell, that is solar cell and LED and photodiode. Photodiode, match the following questions. Solar cell is what? Unbiased. LED is forward bias. Photodiode is what? Reverse bias. And graphs and information, that. And fourth one is what? Anyhow, guarantee question is what? Logic gates. Logic gates means what? Only you want to revise OR gate, AND gate and NOT gate and NAND and NOR. Only this, right? Step by step, PN junction diode, Zener diode, solar cell, logic gate, OR and NOT and next part is what? Half wave rectifier and full wave rectifier, just basic points.
Current circuits, AC circuits, that means alternating currents. In this alternating currents, actually if a coil is rotated in a uniform magnetic field, in that coil induced current or induced EMF are developed. Induced EMFs or currents are developed. This is called electromagnetic induction. So, the concept, that is AC generator, works on the principle of EMI. EMI means electromagnetic induction. So, whenever a coil is rotated in a magnetic field with a constant angular velocity omega, then EMF or currents are induced in the coil. Those currents or EMFs are called induced EMF, induced currents, like that. That is the principle of production of alternating current. Anyway, the equation for the alternating current, actually whenever a coil is rotated in a uniform magnetic field, the flux linked with the coil changes and that flux is written as BA cos theta. If there are number of turns, BAN cos theta, theta can be written as omega t. So, this is the formula for flux. According to the Faraday's law, EMF is equal to minus d phi by dt. By taking the derivative of this equation, we get E is equal to BAN omega sin omega t. In this, BAN omega is called maximum EMF indicated by E naught. Therefore, the equation for instantaneous EMF is equal to E naught sin omega t. If you want current, instantaneous EMF we got, instantaneous current if you want, we have to divide that EMF with resistance according to Ohm's law. So, therefore, instantaneous current is given by I is equal to I naught sin omega t. So, instantaneous EMF is E is equal to E naught sin omega t and I current is equal to I naught sin omega t, where E naught is the maximum value or peak value of EMF and current. E naught is the EMF and I naught is the current. They are the maximum values or can be called as the peak values. I naught is the peak value of current. Similarly, E naught is the peak value of EMF. Now, these are sine curves. Actually, if you draw a graph between time versus EMF or current, time versus EMF or current, this is like a sine curve. That means, for every cycle of AC, in this is called one cycle, this is called positive half cycle and this is called negative half cycle. And this is one complete cycle. In one complete cycle, either EMF or current becomes maximum or minimum for 2 times. Maximum means once here, twice here. Minimum means once here, twice here. Like that, in every cycle, EMF becomes or current becomes maximum or minimum for 2 times. Now, because here we told that the EMF or current varies with time, this is time versus either EMF or current. Because the EMF or current varies with time, it is useful to consider either average value or RMS value. First of all, if any function, not only here sine function, EMF or currents are sine functions, not only that, any function which changes with the time between 2 time intervals T1, T2, how to calculate the average? How to calculate the average means, this is the formula. Of course, here one font was changed, this is integration symbol and this is also integration symbol. So, integral f dt means f function of time into dt and by integral dt between the given time intervals T1, T2. Integral denominator, if you consider, integral dt is equal to t between the limits T1 to T2. So, this is T2 minus T1 and the numerator, depending on the function which varies with the time, we have to integrate that and apply the upper and lower limits. Suppose if we consider half cycle of AC, see here I worked out for the EMF, here current of course, for the current for the half cycle of AC, that is why I have taken the integration limits 0 to T by 2. Suppose for example, if I consider a sine curve like this, 0 to here, that means 0 to T by 2, half of the time period. Between the 0 to T by 2 means for the half cycle of AC, I dt by integral dt, I means I naught sin omega t. Of course, I naught is taken out, sin omega t dt. Anyway, by working out the integration process and substituting the upper limit and lower limit, we get the average current as 2 I naught by pi. Anyway, this final formula, if you remember, it is enough for, because this is not IP exam, so therefore the derivation and all, but this procedure you have to remember. The procedure of integrating and all we have to remember, because there can be given some problems on this integration methods also. So, anyway, for this particular sine curve, the answer for the average is 2 I naught by pi. Similarly, E average is also 2 E naught by pi for half cycle. Suppose instead of half cycle, if we consider full cycle of AC, full cycle of AC means the integration limits we should write 0 to T. Full cycle means one complete cycle. Therefore, between 0 to T if you integrate, you will get the answer as 0. Actually, for this process we need not integrate and all, because this is complete cycle, positive half cycle, negative half cycle, average together, positive and negative becomes cancel. Therefore, average becomes 0. So, average value of AC, either EMF or current, both are equal to 0 for complete cycle. These are for half cycle. Now, here RMS value. If we come to the RMS value, here also some fonts are changed. Actually, RMS value if you want to calculate, again I am telling this is integral symbol. This is also integral symbol. integral symbols are missing here. So, integral IRMS, see here, IRMS square we get, IRMS square is equal to integral I square dt between the limit 0 to t divided by integral dt between 0 to t. Of course, integral dt is t, anyway lower limit is 0, only upper limit is substituted. So, this denominator becomes t only. In the numerator, we substituted I is equal to I naught sin omega t, therefore, this is I naught sin omega t whole square, I naught square sin omega t dt. Now, integrating the numerator, of course, here sin square omega t can be written as 1 minus cos 2 omega t. Sin square theta is equal to 1 minus 2 cos 2 theta, 1 minus cos 2 theta. Again I repeat, sin square theta is equal to 1 minus cos 2 theta. By substituting and integrating, this is all, printing was not proper. Anyway, no need to worry about this. This is the final answer. So, finally, because this is the IRMS square, IRMS is equal to I naught by root 2. So, average values, RMS values. Similarly, RMS value of EMF is E naught by root 2, that is I naught by root 2, this is E naught by root 2. Even if you consider full cycle, half cycle, here if you consider, if you look at this 0 to t I have taken limits of integration. Even if you take the limits as 0 to t by 2 also, that is for half cycle also RMS value you will get the same, that is I naught by root 2 current, E naught by root 2, that is the EMF. So, final formulae, final answers for average EMF and current, RMS current and EMF you have to remember, that is enough for the exams. Now, here I have taken one example. In a certain circuit, current changes with the time according to this equation, I is equal to 2 root 2 t. Now, I need the RMS value of current between the limits, time limits 0 to 4. As I told earlier, IRMS square is equal to integral I square dt by integral dt. I is given as 2 root 2, 2 root t. So, I square becomes 4 t. So, that only I substituted here, integral 4 t dt by integral dt between the limits, they have given already the limits 2 to 4. So, therefore, the limits are from 2 to 4. So, here 4 is out and integral t dt is t square by 2. So, substituting the upper limit 4 and lower limit 2, we get final answer I square. Do not forget this, this is I square is equal to 12 and IRMS finally is root of this root 12, it is nothing but 2 root 3. So, this is one of the important model related to this mathematical approach. So, this is how we calculate RMS. Similarly, you can be asked I average also by giving certain equation of either EMF or current. Next, for example, in doing the numericals, in so many cases, suppose for example, in any numerical AC voltage 220 volt 50 hertz they will give. In any numerical they just give AC 220 volt and 50 hertz for example. Of course, 50 hertz is the frequency, but this 220, what is this 220 or 200 or 400, whatever it is given, unless otherwise mentioned, you remember these values are RMS values. These values are RMS values. So, therefore, we can say that any voltmeter or ammeter, of course, AC voltmeter, any AC voltmeter or ammeter, they measure RMS values. They are not measuring average values or anything, they are measuring RMS value. So, in any numerical, if at all it is given, the value of voltage, whatever the value may be, that you should consider it as RMS value only. And one more simple point is this one. What is this? For example, AC and DC of same voltage. AC and DC, 200 volt AC is there, 200 volt DC is there. Which is more dangerous? Which is more dangerous means AC is more dangerous than DC. Why? Because for example, 200 volt AC means that 200 volt AC is RMS value. If you calculate the peak value, because IRMS is equal to, for example, this is E, ERMS is equal to E naught by root 2. Therefore, E naught is equal to ERMS into root 2. ERMS into root 2. Therefore, E naught is equal to 200 into root 2. Root 2 and approximately 1.4 if you take, you will get 280. Approximately this becomes 280 volt. So, 200 volt AC means 280 volt peak value, whereas DC 200 volt DC means 200 only. So, try to understand this point. 200 volt AC means 280 volt, but 200 volt DC means 200 only. Therefore, we can say that AC is more dangerous than DC. And there is a simple formula here. For calculating the average value of power, power average is equal to ERMS, IRMS, here it is phi, cos phi. IRMS into ERMS is into cos phi. Cos phi is separately called as power factor. Cos phi is known as power factor, and remember that power factor has no units and no dimensions. If at all under the heading of units and dimensions, if they ask what is the unit or dimension of power factor, means no unit, no dimension. So, anyway, ERMS into IRMS into cos phi, ERMS can be written as E naught by root 2, IRMS can be written as I naught by root 2, therefore, E naught I naught by 2 cos phi. So, this is a simple equation for power, average power. Now, after knowing the average power, we are coming to the circuit diagrams. In these circuit diagrams, first circuit diagram is, we have to consider AC connected to a pure resistance circuit. See here, AC source is connected to a pure resistor circuit. If AC is connected to pure resistor circuit, then you can say say that E is equal to E naught sin omega t. E is equal to E naught sin omega t. If you want to write I is equal to, because I is equal to E by R, listen to me properly, I is equal to E by R, E by R, E naught by R. So, this becomes I naught sin omega t. E is equal to E naught sin omega t, I is equal to I naught sin omega t. See, if you observe this equation, here also sin omega t, here also sin omega t only. So, we can say that very important point, in the pure resistor circuit. In the pure resistor circuit, EMF and current are in phase. The phase difference between EMF and current is 0. See this diagram. For example, if the EMF is represented by this curve, EMF is represented by this sine curve, because EMF by resistance is equal to current. Therefore, the magnitude of current will be less. Therefore, the diagram, that is waveform for current, will come like this. The current will come like this. So, this is EMF curve and this is current curve. The magnitude wise, if you speak in the magnitude form, magnitude wise if you speak, current is less than EMF, but whenever EMF is maximum, current is maximum, whenever current is minimum, EMF is minimum. So, you can say that they move together, there is no phase difference between EMF and current. That is why if EMF is represented in a particular way, current is also represented in the same way. That means EMF and current are in phase, they move along with each other. So, there is no phase difference, they are in phase, any terminology you can use. So, this is the circuit diagram, this is waveform and this is phase diagram. This is called phase. This is circuit diagram, that is the wave diagram, and this is the phase diagram. So, remembering only one point, in the pure resistor circuit, current and EMF are in phase. That is the only point to be remembered there. Now, if we consider a pure inductor circuit, of course, the derivations and all, this is not the time to go through. In the case of pure inductor circuit, E is equal to E naught sin omega t and I is equal to, see here, this is I naught, I is equal to I naught sin omega t minus pi by 2. That means, if EMF is like this, if EMF is represented like this, current is represented like this. In the sense, current is I naught sin omega t minus pi by 2. That means, in the pure inductor circuit, current is at the back, means is lagging, current is lagging EMF by pi by 2. Current is lagging EMF by pi by 2, or otherwise you can say that EMF is leading current by pi by 2. So, this point only you have to remember. So, in that, the term L omega is called as inductive reactance. It is nothing but resistance of inductor circuit, that is called as inductive reactance, represented by XL. So, XL is equal to L omega. That is the resistance of the inductive circuit. Resistance of the inductive circuit. Suppose if you consider DC, in this equation L into 2 pi n, L into 2 pi n, where n is the frequency of AC, frequency, generally frequency. Now, if we consider DC, the DC current does not change with the time. DC is a constant steady current. So, therefore, frequency of DC is 0. Frequency of DC is 0. Therefore, if I put this 0, so this is equal to 0, that means XL is equal to 0, that means the resistance of inductor circuit is 0. Resistance 0 means maximum current flows. Maximum current flows. That is why we say that inductor gives or offers easy path for DC, because resistance is 0, and resistive path for AC. This can be asked as a statement question, very important statement question regarding pure inductor circuit. In the case of inductor circuit, current is lagging behind or EMF is leading by pi by 2. These points you have to remember. Next. Now, let me consider a pure capacitor circuit. AC is connected to a pure capacitor. In the case of this AC connected with a pure capacitor, if this is EMF, this is current. So, if the EMF is E naught sin omega t and current is given by, this is I naught sin omega t plus pi by 2. Plus pi by 2. That means here current is leading by pi by 2 or EMF is lagging. Either current is leading or EMF is lagging by pi by 2. So, that is how we say pure resistor, pure capacitor, pure inductor circuit, pure inductor, pure capacitor, pure resistor circuits. So, after knowing these three individually, let us, of course, here also, as in the case of inductor circuit, 1 by C omega is called as capacitive reactance, that is the resistance of capacitor circuit or capacitive reactance. Xc is equal to 1 by C omega, that is equal to 1 by C into 2 pi n. Suppose if you consider DC, in the case of DC circuit, frequency is 0, so this is 0, so this becomes infinity. So, resistance of the capacitor circuit becomes infinity for DC. Infinite resistance means no current. That means the capacitor circuit gives easy path for AC and resistive path or blocks DC. This last line can also be asked as a statement question. These are all confusing, but these are all very, very important. 1 second please. Thank you. Finally, pure resistance circuit. In the pure resistance circuit, current and EMF are in phase. In the pure inductor circuit, EMF is leading current by pi by 2. Remember only one, other automatically can remember. Again I repeat, in the pure resistance circuit, EMF and current are in phase. Take always EMF and current are in phase. In the pure inductor circuit, EMF is leading current. In the pure capacitor circuit, EMF is lagging behind current, of course by pi by 2. Now if you consider LCR circuit, keep these points in mind. Suppose this is EMF, of course I represented like VR. For resistance I am taking, and this is current. In the case of pure resistance, EMF and current are in phase. If a pure inductor circuit, EMF is leading by pi by 2. In the pure capacitive circuit, EMF is lagging behind by pi by 2. So if I represent all these by vectors, and if I say VL is greater than VC, the resultant of VL and VC become equal to VL minus VC. Finally, the resultant of VL minus VC and VR is this. So according to the equations, we can say that voltage or potential drop across inductor is I into XL, potential drop across capacitor is I into XC, and potential drop across resistance is I into R. Net potential is equal to, very, very, very important, net potential is equal to under root of VR square plus VL minus VC whole square. And in this, everything IXL, IXC, IR, if you substitute and if I take I common, this is the formula. And finally, the impedance, of course resistance of LCR circuit is called as impedance. That impedance is given by this formula, very, very important. And again the phase difference, see this. Phase difference in the case of LCR circuit is VL minus VC by VR. VL L omega, VC is 1 by C omega, VR is of course R. Now from this we can give the phase differences in different cases. For example, if L omega is more, then this becomes a positive value. Positive value means then this tan phi becomes positive. So we can say that EMF is leading current. Suppose L omega is less than 1 by C omega, this value becomes negative. Tan theta, tan phi becomes negative means EMF is lagging behind. And very important, very, very important condition is this one. L omega and 1 by C omega are equal, then this value becomes 0, tan phi becomes 0, EMF and current are in phase, phase difference is 0. This is called resonance circuit. In this resonance circuit, because the phase difference is 0, we can say that EMF and current are in phase. If you remember just now I told EMF and current are in phase only in the pure resistor circuit. Therefore, in the resonance condition, EMF and current are in phase. Therefore, the LCR circuit behaves like a pure resistor circuit where at resonance condition. So if I equate L omega 1 by C omega and if I simplify, I will get omega as 1 by root LC. Frequency, resonating frequency, the formula for resonating frequency very, very important, n is equal to 1 by 2 pi root LC. And next important points I am going to discuss. Resonance, if you refer our material, you can find resonance of LC circuit and resonance of LCR circuit. Few points are given in our material. These points are taken as it is from the material. You refer our material. These are very important. You can be asked any point in the exam. So please go through our material. Next, coming to the half power frequencies. In the case of half power frequencies, listen to this graph. In this graph, this power becomes maximum at a resonating frequency. Okay. Next, there are two half power frequency. One is lower than maximum, one is higher than maximum. This is called lower half power frequency. This is called upper half power frequency. Omega 1 is called lower half power frequency. At this lower half power frequency, the circuit becomes or behaves like capacitor circuit. Omega 2, this one, omega 2, this is omega 3 I told, but this is omega 2 can be written. So, omega 2 can be called as upper half power frequency. At this frequency, the circuit behaves like inductive circuit. At this resonating frequency, that is at omega naught, the circuit behaves like resistor circuit. So, again I repeat these 3 points. At this circuit is capacitive, at this circuit is inductive, at this circuit is resistive. These points we have to remember. The difference between this omega 1 and this omega 2, that difference is called bandwidth. That also we have to remember. And next formulae for Q factor. Q factor is resonating frequency by delta omega. Delta omega means omega 2 minus omega 1, that is the bandwidth. Another formula for Q factor is 1 by R into root L by C. Otherwise, Q factor can be written as omega naught L. Omega naught L or omega L means reactance by resistance. Q factor can be calculated from the formula reactance by resistance. Next, very important formula you have to remember is this is wattless current. The formula for wattless current is IRMS into sin phi. What is sin phi? Phi is the phase difference between IRMS and ERMS. IRMS or VRMS, whatever the letter. So, the phase difference between average current and average EMF, if it is phi, IRMS into sin phi is known as wattless current. Sometimes they are giving a numerical also basing on this formula. Next very important thing is transformer. Coming to the case of transformer, listen, remember, transformer is working only for AC. Transformer works only for AC, remember. It is not applicable for DC. Anyway, what transformer will do? So, remember this formula, P is equal to VI. So, what is the purpose of the transformer? Listen to me. High voltage, low current, high voltage, low current can be converted into low voltage, high currents. Again I repeat, high voltage, low currents can be converted into low voltage, high currents or vice versa. That is the use. So, simply remember the formula for power. From that you can say the use of the transformer, high voltage, low current is converted into low voltage, high currents and vice versa. So, that is the use of the transformer. In the case of the transformer, almost all numericals will depend on only 2 formulae. One is this, one is this. This is called transformer ratio. ES, secondary voltage, VS or secondary voltage, EP or VP, primary voltage, NS, number of turns, NP, number of turns, of course S refers secondary, P refers primary. So, the principle of the transformer, again it is electromagnetic induction only, or perfectly speaking it is mutual induction. In the electromagnetic induction, we have two cases, self-induction and mutual induction. When current passing through the primary coil changes, current is induced in the secondary coil. If current in the primary changes, the flux linked with the secondary changes. If the current passes through primary, magnetic field is produced by the primary. If the current in the primary changes, that flux linked with the secondary changes. Therefore, in the secondary EMF is developed. That is the concept of the transformer. Otherwise, mutual induction is the principle. So, this transformer ratio, that is one formula. Another formula is efficiency. Power output by power input. Power output, yes, anyway power is equal to VI, VI or EI. So, secondary EMF, secondary current, primary EMF, primary current. So, this is the formula for this one. And next, as theoretical questions, sometimes we may get energy losses. Energy losses, these are very, very important. Please go through our material. In the last page, near the transformers, they have given one is copper losses and flux leakage, next eddy currents, next hysteresis loss. 1, 2, 3, 4 points are there. 4 points are very, very important. Energy losses, how to eliminate? What are the losses? How to eliminate? This is the case of transformer losses, and these transformer losses can be asked as a statement questions. Please go through this. Anyway, this is the brief analysis of AC circuits. So, this is not the only syllabus I am telling, just we discussed a few important headlines, few important points only. So, remaining you focus on the second exercise. No need to go to the third exercise. Simply after going through the notes, whatever you have with you or our material for concepts, and then you go back to our material, you please work out all the problems in the second exercise. That is enough to get a minimum mark. I mean, I think in the AC circuits, every time they are giving 2 to 3 questions. Generally, they will be giving 2 guarantee. So, in these 2, you can do all the 2 questions 100% if you follow our material and exercise 2. Okay, good luck. We meet again in the next class with another topic. Thank you very much. Thank you for today. Thank you all.
Conversions. We will continue that, and a little bit more we will try to continue now this one, because last time most of the hints I have given. Basing on that, now let us go with some interconversions and some explanations in between that. This is the first one, ethanamide. What is ethanamide? CH3, C double bond O, NH2. This is the ethanamide. This is treated with phosphorus pentoxide. Phosphorus pentoxide is nothing but a dehydrating agent. Therefore, it will remove the water. Phosphorus pentoxide, concentrated sulfuric acid at 170 degrees centigrade will remove the water, and therefore, after the removal of the water, what we are going to get will be the ethane nitrile. This ethane nitrile again on reduction, either in the presence of lithium aluminum hydride or in the presence of hydrogen nickel, reduction takes place, the bond will break here, hydrogens here will add, and therefore we are going to get a primary amine, ethanamine, aminoethane. This one again, ethanamide with lithium aluminum hydride, straight away reduction. Reduction means again we are going to get this amine finally. So once you get this C also here amine, once you get this amine here, primary aliphatic amine with NaNO2 HCl, disonium salt, we are going to get the alcohol plus nitrogen. Remember in the conversions, aliphatic amines will give alcohols, whereas aromatic primary amines on diazotization will get converted into benzene diazonium chloride. That is the difference. Benzene diazonium chloride with a hypophosphorus acid if you are going to do, then we are going to get the benzene. With ethyl alcohol also we are going to get the benzene. Whereas with the hydrofluoroboric acid, we are going to get the fluorobenzene. So aliphatic primary amines, alcohols, aromatic primary amines, diazonium salts, from that again the remaining conversions. Important one. Next one, acetic acid with a different one I given there. Acetic acid with chlorine red phosphorus, that is nothing but the HVZ reaction. Alpha halogenation takes place. Since there only one mole of chlorine is present in the red phosphorus, we are removing only one alpha hydrogen, so that we are going to get the monochloroacetic acid. Suppose one more chlorine has been added, then we are going to get the dichloroacetic acid. One more chlorine in red phosphorus, trichloroacetic acid. Let this is A, this is B, this is C. Then they may ask you what is the acidic character. Basing on the negative inductive effect, if you are going with this acidic character, more the number of electron withdrawing groups, more will be the acidic character. That is why the C will be greater than B, greater than A. Negative inductive effect. Then next one, acetic acid with ammonia. This is another one. Acid plus ammonia. First we are going to get the ammonium acetate, a salt. This ammonium acetate on heating again. So heating means it again loses the water. Therefore we are going to get the amide. This is also very important one. Amide we are going to get. Here, if I write here bromine NaOH, otherwise bromine KOH, Hofmann's degradation reaction, Hofmann's bromamide reaction. Therefore, one carbon less amines we are going to get, and that is the reason we are going to get the methanamine, otherwise aminomethane. So just interconversions, and again during that one I am telling the naming reactions also. Hofmann's bromamide reaction will lead to one carbon less primary amines. Next one, acetic acid with ethyl alcohol, that is nothing but esterification. So in the esterification, this is an acid and alcohol C2H5OH, otherwise CH3CH2OH, in the presence of the sulfuric acid. Very important point to be remembered, in the case of an acid, COH cleavage will take place, whereas in the case of alcohol, OH cleavage will take place. We think that acid means it should release the proton, but during the mechanism we have seen that there is a bond between C and O will be cleaved here, whereas between O and H. Therefore, CH3CH2O, then this acylation takes place. This is an acyl group. acylation takes place to the alcohols, thereby an ester formation takes place. The formation of an ester here is helped with the concentrated sulfuric acid, which can act as a dehydrating agent as well as the catalyst. So, remember once again, OH of the alcohol and CO of the acid are going to break. Then with this heat directly, CH3 C double bond O OH, take one more mole of the acid, then heating loses the water molecule. Therefore, we are going to get an acid anhydride. This one generally we call it as the ethanoic anhydride, IUPAC name, but nowadays we are calling this one as ethanoyl ethanoate. Ethanoyl alkanoyl alkanoate model, ethanoyl. In the esters we say alkyl alkanoate, in the case of the acid anhydrides alkanoyl alkanoate, therefore ethanoyl ethanoate. Next one, ethyl bromide with cation. In the last class I told, to increase the carbon number we are using this, therefore ethyl cyanide. Ethyl cyanide complete hydrolysis, carboxylic acid, partial hydrolysis, we are going to get amide, partial hydrolysis. That partial hydrolysis bromine NaOH, just now I said half mass bromamide reaction, remembering many times the same reactions. By next Sunday, by this time, hope you will be going to the examination hall for writing the examination. So, therefore, remembering many times the same concepts will be more useful for you. Important one, definitely will be going to get these models. So, therefore, bromine NaOH, this one is an amide, is getting converted into NH2. Then chloroform KOH, that is nothing but the phenyl isocyanide test. So, primary amines will respond to the phenyl isocyanide test, where we are going to get the isocyanide. Methyl carbylamine, IUPAC name, methyl carbylamine. So, increase in carbon number, partial hydrolysis amide, half mass bromamide reaction, either NaOH or KOH, one carbon less, and that is getting converted into isocyanides, phenyl isocyanide test. Next one, ethyl bromide with sodium methoxide. This is nothing but Williamson synthesis. Whenever you take the sodium methoxide like this, where there will be two lone pairs of electrons on oxygen and a negative charge ion, that is attacked by ethyl bromide, where this will be minus and plus. Thus, this one will come and attack here. Hence, we are going to get an ether, unsymmetrical ether, because oxygen is surrounded by two different alkyl groups, methyl group and ethyl group, that is why unsymmetrical one. This follows SN2 mechanism, a transition state is going to be formed. In this case, always remember, in the Williamson synthesis, to get an ether, primary alkyl halide should be there, primary alkyl halide. Suppose, if we are going to take now just one second. Tertiary alkyl bromide. This is now treated with, say, sodium ethoxide. I have taken here the primary alkyl halide, listen carefully. Here I am taking the tertiary alkyl halide. Now, in the presence of the strong base, there is an obstruction of proton from this. Thereby, the bond will break like this. You will get a stable carbocation and minus. Once there is a stable carbocation has been formed, then it is an SN1 mechanism. Then this strong base will remove the proton, will abstract the proton from this one of the alkyl group. Thereby, this hydrogen and will be removed, a double bond will be formed here, and thus we are going to get like this, isobutene. Understand that carefully. Primary alkyl halide will only give the ether. Tertiary alkyl halide or secondary alkyl halide also will give the alkene as a major one. That is why in order to get an ether, you just check whether the alkyl halide is primary or not. Then only you will get the ether. This follows SN1 mechanism, this follows the SN2 mechanism. Now, the next one followed by this here, dilute HI, generally here concentrated HI. If you take now like this, CH3, CH2, O, CH3, unsymmetrical one, then whenever you treat this with 1 mole of HI, here is the lone pair, H plus, I minus, it is a strong acid, therefore can create H plus, I minus, the lone pair of electrons will go to this, and thereby a transition state is going to be formed. Here also a transition state. The negative part of this one will come and attack always the lower alkyl group, and a transition state is formed here. Then the bond is going to break. Then we are going to get the CH2, CH3, CH2OH plus methyl iodide. So, whenever it is an unsymmetrical ether, always the iodide should attack the lesser number of carbon atoms alkyl group. So that we will get the methyl iodide, the remaining part will be alcohol. Suppose in place of this dilute concentrated HI, if you take excess of HI, then at high temperature heating, then the formed ethyl alcohol also will get converted into ethyl iodide. Therefore, the answer will be 2 moles of 1 mole of methyl iodide, 1 mole of the ethyl iodide. So, when you take this CH3, CH2, OCH3, concentrated HI, your answer will be CH3, CH2OH plus CH3I. Suppose if it is excess of HI, heating, then 1 mole of ethyl iodide, 1 mole of methyl iodide plus water. This is also very, very important. Now, coming to this anisole, suppose HI. In the last class I told never the bond between oxygen and the carbon will break because of the double bond character, because of the resonance. Hence, the bond you have to break here. This is minus, this is plus, minus. So, therefore, H plus will come and attack here. You will get the phenol plus methyl iodide. Always break the bond here, not in between these two. Suppose if I get like this, then again break the bond here, then here H, here I. The in-text question what they are given is this benzene ring. Then again break here, here H, here I. Once you break here, you will get it here the benzyl carbocation which is more stable, that is why benzyl iodide and phenol we are going to get. Suppose we have like this. You are observing a tertiary one here, so break it here, then here add the iodide, here H. This is more stable, no, tertiary carbocation, that is why break here, this one iodide, here OH. That is what about in the ethers you have to remember the Williamson synthesis. Primary alkyl halides will give the ethers, secondary and tertiary alkyl halides will give alkene. HI bond cleavage, one unsymmetrical one, lower alkyl group will get the iodide, the remaining one alcohol. Then once it is then anisole or this cyclic compounds like this, then wherever the oxygen is present in between oxygen and alkyl, that one you break it, not between these two, then add H here, I here. This is the in-text question for the last week discussion, just for understanding I given. Bromine is here, NO2 is here, magnesium ether, that means Grignard reagent formation takes place. That is why we are going to get now NO2 will be present as it is on the meta position. Like this. Then again carbon dioxide. Carbon dioxide will act as the weak electrophile. This is the CO2. The pi bond will shift like this, minus and plus. So this one. Electrophile will come and attack here. You will get OMGBr. The bond will break here. This C plus will go and attack here to the benzene ring. Then we will get this addition 1. Then on hydrolysis, the bond will cleave here such that we are going to get here H, here OH, 3-nitrobenzoic acid. This one again. This one alpha carbon, in the last class we discussed that. KMnO4 KOH, alpha carbon will get converted into carboxylic acid. This one also will get converted into carboxylic acid. Therefore, two sides we got first salt and then acid. Therefore, it is benzene 1,4-dicarboxylic acid, terephthalic acid. This is all for the last class applications again, which are there in our in-text questions of NCERT. That is why I just selected this. This one again the same. Cyclohexene, KMnO4, H2SO4 heating, oxidizing agent. Therefore, wherever the double bond is there, it will break. Then this one will get converted into acid, this also above and below. Therefore, it is adipic acid, hexane 1,6-dioic acid. In this only, suppose if they give you like this, 2-butene with KMnO4, H2SO4, acidified KMnO4 if they give, just break the bond like this, convert this into acid, again convert this also into acid. 2 moles of acid we are going to get in acidified KMnO4. CH3, CH, CH2. Again, suppose if it is a KMnO4, H2SO4, break this one, acetic acid, and this one will convert into formic acid. Otherwise, they may also give CO2 plus H2O. So, whenever we see the acidified KMnO4, the double bond should break and acids we have to get. Then this one, this is nothing but the tolerance reagent test. The aldehydes which contain alpha carbon atom or aldehydes themselves will get converted into an acid. Here my point why I have selected this one is, in the tolerance reagent we know that a bright silver mirror is going to be formed, that is no doubt. But at the same time the remaining component will get converted into acid. The aldehyde group will get converted into acid. During the conversions it will be useful for you. So, in the tolerance reagent test, aldehyde will be converted into an acid. This one acidic character. Once the carboxylic acid here loses the proton, you are going to get a carboxylate ion. If the electron withdrawing group is attached, then this will be stabilized. The magnitude of the negative charge will be reduced and therefore it becomes more stable. Hence, this will be ready to lose the proton, because after losing the proton it becomes more stable. The last one, methoxy group. Methoxy group there, again after losing the proton here you will get a carboxylate ion. Methoxy group is an electron releasing group, thereby the magnitude of the negative charge will increase, makes it to be unstable. That is why it is not ready to lose the proton. Hence, electron withdrawing group will increase the acidic character, electron releasing groups will decrease the acidic character anywhere. Hence, the order of acidic character here is NO2 attached electron withdrawing group greater than the benzoic acid greater than the paramethoxy benzoic acid. Similarly, the same one I have taken CF3 I am taking here because it is a most electron withdrawing group. Therefore, this is more acidic when compared to this one. Methyl group is an electron releasing group. This one, ethylene with HI, we are going to get ethyl iodide. Ethyl iodide with aqueous potash. Last class I told aqueous means we have to substitute this with the OH. Alcoholic means we have to remove the hydrogen and halogen. So, therefore, aqueous ethyl alcohol. Ethyl alcohol with concentrated sulfuric acid at 140 degrees. 170 will remove the water. 140 degrees we are going to get an ether. So, that is why you have to take the 2 moles of the ethyl alcohol and remove the water, then we are going to get the symmetrical ether here. So, remember 140 will give the ether, 170 dehydration. Then it is a symmetrical ether with 1 mole of HI, concentrated one, anything it is the same answer you are going to get whether you break here or here. We are going to get finally ethyl alcohol and ethyl iodide. I repeat, if unsymmetrical ether, the lower one should get the iodide, lower alkyl group. It is a symmetrical, no problem, ethyl alcohol and ethyl iodide. If they say here the excess of HI, this one also will get converted into ethyl iodide. This one, 2-bromopropane with alcoholic KOH. Alcoholic KOH or NaNH2. Last week we have studied both of them will act as the dehydrohalogenating agent. So, we are removing the bromine and hydrogen so that we are going to get the propene. Propene in the presence of HBr peroxide. CH3, CH2, CH2Br. N-propyl bromide. Anti-Markovnikov's rule, where we are going to get the primary alkyl halide as the major one. In the peroxide effect, Karash effect, anti-Markovnikov's rule, free radicals are going to be the intermediate stage formed. Peroxides will be formed in this one. Heat, when you see heat or electricity or the light or the peroxide, they will definitely give the free radicals. That is why we say that anti-Markovnikov's rule follows the free radical addition. The stable free radical formed here is no doubt the secondary free radical only, but during the mechanism we have seen 1-bromopropane is formed as a major one, anti-Markovnikov's rule. Once again, this is an unsymmetrical alkene because the double bond is surrounded by two unequal carbon atoms. Treated with HBr peroxide, we got anti-Markovnikov's rule followed, 1-bromopropane. Suppose the same, if it is treated with HCl in the presence of peroxide, there won't be any peroxide effect here. Your answer will be 2-chlorobutane will be the major one, because the HCl is having the greater bond dissociation energy. Therefore, it is going to break into ions. Once it is ions, then it follows only the Markovnikov's rule, and that is the reason the 2-chloropropane, otherwise isopropyl chloride, will be the major one. Even with HI also, we are not going to get any anti-Markovnikov's rule there, even though it is a peroxide, because HI no doubt has the low bond dissociation energy. They dissociate into free radicals, but immediately these two free radicals will recombine to form the iodine. They are highly reactive, that is why they immediately form the iodine. That is why anti-Markovnikov's rule is observed only with HBr, not with HCl, not with HI. Generally, they will give with HCl. On the arrow mark HCl peroxide they will give. So, as soon as we see the peroxide, do not immediately go with the 1-chloropropane, it should be the 2-chloropropane. Then this is treated again with sodium methoxide, primary alkyl halide, just now I said, therefore, we can easily get the ether, unsymmetrical ether. Then IUPAC name for this one. This is all some questions you made mistake in the grand test. No major functional group here, therefore, we have to follow the lowest sum rule. Neither COOH nor the COOH nor the CHO nor the cyanide are present. You have to follow only the lowest sum rule here. Therefore, if I write from here 1, 2, 3, 4, 5, 6, then we are going to see 1-chloro, 2-nitro, 4-methyl benzene, first option. Lowest sum rule should be the same. Here 1-chloro, 4-methyl, 2-nitro, whereas this is 1-chloro, 2-nitro, 4-methyl. What is the correct order of decreasing stability of the following cations? Now, here is the lone pair of electrons present that will involve in resonance. Here only hyperconjugations are present, positive inductive effect or hyperconjugation. Here it is the negative inductive effect. This positive mesomeric effect will decrease the magnitude of the positive charge makes it to be more stable, then hyperconjugation, then the negative inductive effect will destabilize the carbocation. That is why we say that this one will be more stable, second one, than the first one, then the third one. Whenever we have like this positive charge here, oxygen is immediately present, then there will be a positive mesomeric effect. But whenever we have like this far away, then we have to take only the negative inductive effect for this. This will stabilize, this will destabilize. That is why this one will be first, resonance stabilized will be more stable than the inductive or hyperconjugation, but this is the negative one, negative inductive effect, that is why it is destabilized. This one you start with ethanoic acid, CH3, C double bond O, OH plus sodium, sodium ethanoate, then that is treated with the soda lime. Therefore, I said last time we had to break here, then your answer will be the methane. Ethyl chloride with alcoholic KOH, ethylene. Then ethylene when treated with dilute sulfuric acid, water should attack. Therefore, we are going to get the ethyl alcohol. Then this one you take it as the ethyl alcohol, X as an ethyl alcohol. Ethyl alcohol treated with concentrated sulfuric acid at 170. Just now I said you are going to get the ethylene. Ethylene with bromine, we are going to get 1,2-dibromoethane, bromine in CCl4. Double bond should break. Last time I told bromine in HNU, bromine in light, free radicals will be formed, then allylic substitution. Here it is CCl4 inert solvent addition. Alcoholic KOH, first we are removing one bromine, one hydrogen. Again NaNH2, last time we discussed bromine and hydrogen, therefore your answer will be acetylene. Then coming to this one, acetylene, whenever again it is treated with the sodium in liquid ammonia, the sodium will replace the acidic hydrogen. Therefore, we are going to get the sodium acetylide. The hydrogens attached to the triply bonded carbon atom or sp carbon atom are more acidic, that is why this hydrogen will be replaced by sodium. Suppose if this is again treated with methyl iodide, remove this sodium and this iodine, so that we are going to get the propyne. So therefore, sodium in liquid ammonia followed by Rx, this will help in increasing the carbon number of alkynes. We have started with 2 carbon atoms, now you got it 3 carbon atoms alkyne. This is possible only for the alkynes. Now suppose if I am writing like this, here there is no acidic hydrogen, methyl groups are present in the 2-butene, that is why 2-butene do not react with sodium and liquid ammonia. But when I take the 1-propyne, yes, 1-propyne has 1 acidic hydrogen, it can react. More the number of acidic hydrogens, mole will be acidic, therefore acetylene is more acidic than propyne. Then ethylene do not contain any acidic hydrogens, because in the case of this one carbon is sp2 hybridized, that is why that hydrogens are not considered to be acidic hydrogens. Next, pKb value is highest for whenever there is an electrons present. Suppose I take the ammonia, lone pair of electrons, it can donate and can act as the Lewis base. To this now R is attached, alkyl, then it becomes amines. Then the alkyl groups are electron releasing groups. Therefore, the lone pair of electrons can be easily donated. So whenever the electron releasing groups are present, the electrons can be easily donated, therefore they can act as the more basic one. Hence, amines are more basic than ammonia. But in the case of the aniline, aromatic amines, the lone pair of electrons present on the nitrogen is in resonance. That is why they are not readily available to donate, hence the basic character will be less for that. So, basic character, alkyl amines more basic than the ammonia, more basic than the aromatic amines. So, coming to this one, pKb value is highest means Kb value is less, Kb value less means less basic. So, now this one, whenever there is an electron withdrawing group is attached, this is an electron withdrawing group, then the electrons are strongly given to the benzene ring, therefore no availability and hence it becomes less basic, therefore less Kb, more pKb value in this one. And in this the more basic will be this one. After that comes here this, because here lone pair of electrons are involved in resonance, but because of the methyl group there may be some chance of donating. But in this case the lone pair of electrons are completely given to the benzene ring. So, that is why the basic character will be least for this one or highest one for this one, then comes this, then comes this, then this one. That is what just now we are saying. Propene with HBr, Markovnikov's rule, HBr with this one anti-Markovnikov's rule. Markovnikov's rule here, X will be the isopropyl chloride and Y will be the N-propyl chloride. This Markovnikov's rule follows electrophilic addition. Electrophile is going to first attack, H plus will going to be first attacking. That is why it is an electrophilic addition, whereas this one will be the free radical addition. Now check accordingly. X is isopropyl bromide, Y is N-propyl, correct. X and Y are positional isomers, correct. 2 chloro, 1 chloro, you will get it. Formation of X is electrophilic addition, this one, yes. Formation of Y is electrophilic addition, wrong, it is the free radical addition. Anti-Markovnikov's rule follows the free radical addition. Then soda lime, take ethanoic acid. Ethanoic acid with soda lime, we are going to get the methane, 1 carbon less. Methane in the presence of chlorine, 1 mole is given, methyl chloride. Methyl chloride with sodium in dry ether, Wurtz reaction. Therefore, we have to take the 2 moles, then we are going to get the ethane. Wurtz reaction is useful in preparation of symmetrical higher alkanes. In the case of the unsymmetrical one, if you are going to take, for example, one is the methyl chloride, another is the ethyl chloride, we are going to get the 2 products, 3 products like this. Methyl and methyl will get combined, ethane, methyl and propyl, propane, ethyl and ethyl, butane. In this is an unsymmetrical alkane. Therefore, unsymmetrical alkane can be prepared by crossed Wurtz reaction. But the separation becomes difficult because of less difference in their boiling points. For the preparation of unsymmetrical alkane directly, we can use the Franklin reaction, which is not there in the NCERT. The same one. Now this one, hydrogen, palladium, barium sulfate, that is nothing but the Lindlar's catalyst. Lindlar's catalyst will be useful in partial hydrogenation. The triple bond will be converted into the double bond, partial hydrogenation. Lindlar's catalyst is also used to convert the acyl halides, that is benzoyl chloride into the benzaldehyde, Rosenmund's reaction. Here it is used as a partial hydrogenating agent. Then this one just now I said acidified KMnO4, wherever the double bond is there, break that and we are going to get the acid, 2 moles. Then take this one, ozonolysis, ethylene with HBr, ethyl bromide with the alcoholic KOH, again ethylene we are going to get. Then ozonolysis, the bond will break, here O, here O. Then we are going to get the 2 moles of formaldehyde. but what he is giving here is the acetaldehyde and the formaldehyde. That is why go with the propene. CH3, CH double bond this one with the HBr. Then alcoholic KOH, again will remove this, we will get the propene. Propene on bosonolysis, the bond will break here, therefore 1 mole of acetaldehyde, 1 mole of the formaldehyde. Like that, depending on the last product formed, select here. The last one. Same one. Lindlar's catalyst will give the cis compound, whereas the NaNH3 will give the trans. This is an aromatic amine. So that's why just now I said aniline, when treated with NaNO2 HCl, we are going to get the benzene diazonium chloride. Benzene diazonium chloride with the CuCN, cyanobenzene. Cyanobenzene on reduction, cyanides on reduction, just now we have seen in the first reaction itself, amines. That's how we are going to get primary amine. Right. Thank you.
Good morning, students. Can you hear me? Okay. I already told you in the last video also, we are not going to teach anything extra. What we already studied and last minute final revision, what we need to revise once again, those questions I am revising now. Please all of you focus your attention and listen carefully. Chances are there we may get these models, and from chemical bond and periodic table there is a possibility to get 3 questions. If chemical bond 2 questions are given, periodic table 1, or other vice versa. So please concentrate. Which of the following molecule does not obey octet rule and also has lone pair on the central atom? Does not obey octet rule. Octet rule means Lewis theory, 8 electrons in the outermost shell. Suppose if you take CCl4, CCl4 has, see, total 8 electrons. This is 8 electron. Carbon surrounded by 4 chlorine atoms, 1 chlorine, 2nd chlorine, 3rd chlorine, 4th. So total number of bond pair electrons are 4. So 4 bond pairs means 8 electrons. PCl3, 3 bond pairs and 1 lone pair. So 3 plus 3 2s are 6 plus 2, 8 electrons. Ammonia, same structure, same as that of it. NH3, it also has 8 electrons. Coming to SCl4, SCl4, it has 4 bond pairs, 4 bond pairs, seesaw structure, 1 lone pair. So 4 2s are 8, 8 plus 2, 10. So which of the following does not obey octet rule is last, and also has lone pair electrons on the central atom. See, octet not more than 8 electrons plus 1 lone pair is also present. So answer is 4th option. Next, among the following, the total number of species not having 8 electrons around the central atom. This is the 2023 NEET question. Here you just have a look at this. Ammonia has 8 electrons with 1 lone pair, 3 bond pairs. CCl4, 4 bond pairs, no lone pairs. So these two have 8 electrons, 8 electrons. The species which are not having 8 electrons are AlCl3. AlCl3 has only 3 bond pairs. it has 6 electrons, sextet configuration. So, this is not having 8 electrons. Beryllium chloride has only 2 bond pairs, means 4 electrons, not completed octet. And PCl5 has total, this is the structure of PCl5. Here central atom gets 10 electrons. So, not having 8 electrons means aluminum chloride, beryllium chloride, PCl5. Remaining 2 have 8 electrons. Next question. Which of the following is not an exception to octet rule? Octet rule, see, which is not an exception to octet rule. You see the examples. This is an exception to octet. 4 electrons, 14 electrons, 12 electrons, but CO2 does not have any such controversy. It has 8 electron species. So, it is not an exception. Next. 2 elements X and Y have the following configuration. See the configuration, children. Here X has 2 electrons in the outermost shell. X has 2 electrons. So, number of electrons in the valence shell will take part. So, it has 2 valence electrons. And Y, if you take Y, the last shell contains 7 electrons. For 1, 2, 3 group elements, number of valence electrons, whatever the electrons present in the last shell will take part directly, whereas for 5th, 6th, 7th group elements, 8 minus group number rule has to be taken. Here 7 electrons are there, so we need to take 8 minus 1. So, this is equals to, if you crisscross this, the formula will be XY2. So, answer is this. Next one. Which of the following pairs will form strongest ionic bond? See this question, so many people have doubt. Several times many people ask me this doubt. See, they are getting confused near strongest ionic bond, strongest ionic character. Ionic character means conditions required for the formation of cation and anion. If large atom, large cation, small anion is taken, that satisfies all the conditions. CSF is having strongest ionic character, because all characters required for the formation of cations is satisfied by cesium and anion is satisfied by fluoride. So, strongest ionic character is for CSF. Now, but question asked is strongest ionic bond. Strongest ionic bond means we need to consider lattice energy factor. So, lattice energy is directly proportional to charge, inversely proportional to size. So, smallest atom or ion is having highest lattice energy. So, here chloride, you see this example, LiF lithium is having smallest size. So, it has high lattice enthalpy. So, LiF is the strongest ionic bond. Ionic character is more for CSF, ionic bond strength is more for LiF. This question, in the previous grand test we got this. Ionic bond formation is a redox reaction. Of course, it is correct. For example, if you take NaCl, sodium atom loses electron, so it is oxidation process. Chlorine atom gains an electron, so reduction. So, ionic bond formation is an example for redox reaction, whereas ionic reactions are not redox reactions. For example, if you take any ionic reaction, ions are involved in the formation of a compound. Example, HCl plus NaOH, NaCl plus H2O. In this case, or example, beryllium silver nitrate, NaCl plus AgNO3. If you take, we will take that example. NaCl plus AgNO3 gives rise to AgCl plus NaNO3. Now, look at this here, Na plus Cl minus, Ag plus NO3. This is the solid formed precipitate. So, here no ion is undergoing any change in oxidation state. So, it is an ionic reaction, but it is not a redox reaction, because none of the species oxidation state is changed over here. Next. among the following which compound will show highest lattice enthalpy? Lattice enthalpy, just now I told, lattice enthalpy directly proportional to charge, inversely proportional to size. Here see everywhere fluoride ion is common. So, we compare with cations. Smallest cation out of all those 4 is Na. Na plus is the smallest cation out of these 4. So, Na plus has the highest lattice enthalpy. And among the following highest polarizing power, polarization power, polarizability, 2 terms are there. Polarization power means tendency of cation to attract electron cloud from anion. Tendency of cation to attract electron cloud from anion is called its polarization power or polarizing power. Now you see this Li plus, Be2 plus, Al3 plus, Si4 plus. You have to take charge. Charge, if you take Si4 plus as the largest charge, moreover size is small for it. So, highest polarizing power is for large, highly charged cation. So, answer is Si4 plus. Highest polarizability. For anionic bond formation, we require high polarization power of cation, high polarizability of anion. If you take polarizability, polarizability is considered for example, you see tendency of anion to shut down its negative charge is called its polarizability, to lose its negative charge. Fluoride ion being very small, most electronegative atom, it will never lose its charge. Whereas as we move down the group from fluorine, chlorine, bromine, iodine, if you go down, what happens to size of the ion increases. So, iodide ion is largest size and moreover less electronegativity. So, this iodine atom cannot hold the negative charge firmly. The one which loses its negative charge is iodide ion. So, that is why polarizability increases down the group. Polarization power is for cation, polarizability is for anion. For Fazan's rule, we decide a covalent bond based on the polarizing power and polarizability. So, as we move down the group from fluorine to iodine, size increases. So, iodide ion being largest ion with the smallest, less electronegative atom, it cannot hold the negative charge firmly. So, it can shut down its negative charge easily. Hence, polarizability is more for iodide. And if you take polarization power, Na plus, Mg2 plus, Al3 plus, if you see all these belongs to the same period. As we move across a period, what happens to size? Decreases. What happens to charge there? Increases. So, size decreases, charge increases. So, highest polarizing power is for Al3 plus. CuCl, very important question. CuCl has more covalent character than NaCl. Reason? Actually, NaCl has chloride ion, CuCl has chloride ion, both have chloride ions. Suppose if you take Na plus and Cu, both belongs to same group but different subgroups as per Mendeleev's classification, 1A, 1B. So, sizes do not differ much, charge also same. Then how do we decide? Charge is same, size is almost same. In such case, we have to consider configurations. Na plus gets octet configuration, Cu plus gets pseudo octet configuration. Pseudo inert gas configuration is nothing but getting 18 electrons. It gets 3s2, 3p6, 3d10. 18 electrons in the outermost shell after losing 4s1 configuration. So, 18 electron and it is getting 2s2, 2p6 octet configuration. The one which gets octet configuration is ionic bond, which gets pseudo inert gas configuration is covalent bond. For example, AgCl, example CuCl, example zinc chloride, these are all getting pseudo inert gas configurations, hence they are considered to be covalent in nature. Among lithium chloride, beryllium chloride, boron and the covalent bond character. Few minutes back I discussed the same question. Now you see anion is same in all the 4. So, lithium, beryllium, boron, carbon all belongs to the same second period. As we move across a period, size decreases, charge increases, Li has plus charge, beryllium 2 plus, boron 3 plus, carbon 4 minus. So, as we move across a period, charge increases. As the charge increases, actually here depending upon the combining atom, if it is oxygen it will get positive charge. So, here as we move across, charge is more, higher the magnitude of charge, greater is the polarization power, hence more is the covalent character. So, answer is this one. What is the formula of a metal phosphate if formula of its chloride is MCl2? MCl2, metal chloride Cl2, as metal is combining with 2 chlorine atoms, metal valency is 2, chlorine valency 1. So, after crisscrossing we get MCl2, right. So, from this we will come to know that metal is in oxidation state, metal has 2 valency. Now, same metal if it forms a phosphate, phosphate is PO4, 3 minus, so charge is 3. So, if you crisscross this we get M3PO4 taken twice. So, answer will be M3PO4 taken twice, first option. Statement 1, this is also previous question, even in JEE Mains paper also they asked. Sodium sulphate is soluble in water while barium sulphate is insoluble. Generally sulphate salts are less soluble. If you take second group hydroxide, solubility increases down the group, second group sulfates solubility decreases down the group, because lattice energy will not play a role. As we move down, lattice energy decreases with increase in size, but hydration enthalpy factor is to be considered in case of large anions. Whenever large anions like sulphate, carbonate etc. are present, we should not depend on lattice enthalpy, we should depend on hydration enthalpy. So, for barium sulphate, hydration enthalpy decreases. So, hydration enthalpy is less when compared to lattice enthalpy, hence barium sulphate is less soluble when compared to sodium sulphate. Next, day 2 bond is present in the molecule. In which of the following there is a day 2 bond? Day 2 bond is nothing but coordinate covalent bond. NH3 there is no day 2 bond, only 3 covalent bonds are present. Carbon dioxide, it has normal 2 bonds, no day 2 bond, both are covalent only. If you take CO, carbon monoxide, carbon has 4 electrons, oxygen has 6 electrons. This is Lewis dot structure. So, we can put a double bond between these two. Now, with the help of this lone pair, because even after bond formation it is carbon is getting only 6 electrons, oxygen is satisfied but carbon not satisfied. So, we will donate this pair of electrons. So, we can put a triple bond between these two, one lone pair here, one lone pair, and this is the day 2 bond. So, carbon monoxide contains a day 2 bond from oxygen to carbon. PCl5, all 5 bonds are single bonds only, there is no day 2 bond. Which of the following is zero overlapping of orbitals if Z axis is taken as internuclear axis? This comes in valence bond theory, VBT. So, in valence bond theory, all of you please listen. Valence bond theory was proposed to explain directional nature of a covalent bond, strength of overlap of orbitals. Greater the strength, greater is the directional nature and strength, both are explained by valence bond theory. So, now if you take Z axis as internuclear axis, I am taking Z axis as internuclear as per this, which of the following is zero overlap of orbitals? You see which axis will take same orbitals, PZ, PZ. Z axis is taken, PZ, PZ will form a sigma bond because axial overlap of atomic orbitals takes place. Same Z axis as internuclear axis, a PZ orbital can overlap with S orbital. This is PZS sigma bond. So, this is sigma bond formation, this is sigma, both are possible. PZ, PZ is sigma, PZS is also sigma. Now, you see PZS sigma bond, PZ, PZ sigma bond. Now, PX, PX. For example, z axis is the internuclear axis. Here if you take px orbital, these two overlap laterally. Lateral overlap results in the formation of a pi bond. This is px. This results in the formation of a pi bond. So, this is not sigma bond. Second thing, py, it is not given here, but py, if you take, this is also expected to be a pi bond only. Px is pi bond, py is also a pi bond along z axis. And one more point, pxs along z axis, if you take px with s orbital, this is called 0 overlap, because here node is there. So, electron density is found only in lobes. At this particular point there is no electron density. So, even s orbital overlaps, that overlap is 0 overlap because there is no significant bond formation. So, as per this 0 overlap takes place here. Another example, if you take py with the s orbital, it is also a 0 overlap. One more, this is px s, this is py s, both are considered to be 0 overlaps. Another one, children listen carefully ma, z axis is the internuclear axis, one px orbital, one py orbital, this is px, this is py. These two do not form a bond, resulting bond formation does not take place. Reason is, here the two p orbitals orientation is different, symmetries are different. When they have different orientations, bond formation cannot take place. So, px, py bond formation does not occur. See all these three cases. In our refresher material, so many questions of this model are there. Hope you understood. Okay. Some statements about valence bond theory are given below. Just now I told, the strength of a bond depends upon extent of overlapping. Greater the extent of overlapping, strength of the bond is more. For example, 2p overlapping greater than 2s 2p greater than 2s 2s. For example, if 1s overlapping is given, that 1s is the strongest among all. So, always 1s comes first. Generally they will give from here onwards, pp, sp, ss, that is the order of overlap of orbitals. But out of all these, when compared to 2s 2s, 1s orbital overlapping strongest among all. This is followed by pi pp, pi 2p 2p. This is the least one. Next, if z axis is the molecular axis, then pi molecular orbitals are formed by, this already I discussed. Z axis is the internuclear axis, pz is a sigma bond, px py is 0 overlap, pzs sigma bond, px leads to pi bond formation. So, because the orbital overlap take place like this, this leads to the formation of a pi bond. So, answer is px. Which of the following is an example of 0 overlap? 0 overlap, you see the diagrams, this is pxs, pxs along z axis is considered to be 0 overlap, because at nodal region no electron density. You see this pz with s, sigma bond formation. This is px pz. A px orbital and pz orbital overlap also does not lead to any bond formation because of that no electron density at the nodal region. So, both answer is 1 and 3 are considered to be 0 overlaps. According to valence bond theory, the bonds in methane are formed due to the overlap of, this is one of the major drawback of VBT. The bonds present in methane are formed due to the overlap of methane CH4, carbon configuration 1s2, 2s2, 2p2, excited ground state no bond formation, in excited 2px1, 2py1, 2pz1. This is the electronic configuration in the excited state. Now, in methane, the bonds formed, methane is carbon forming bonds with hydrogen. So, if you take hydrogen, hydrogen has only s orbitals. So, this s orbital of carbon with s orbital of hydrogen, one SS, sigma SS bond, and these three are p orbitals of carbon. The p orbitals of carbon combines with s orbitals of hydrogen. So, we have 3 sp bonds, 3 sp sigma bonds. So, it has 3 sigma sp bonds, 1 sigma ss bond. As all bonds are not identical in methane, methane as per VBT all bonds are not identical because of different overlaps, but hybridization concept explains the equivalence of bonds. One of the major drawback of VBT is equal bond lengths are not, equivalence of bonds is not explained by VBT. Next, which of the following boils at high temperature? Boils melts. Actually, melting and boiling points are more for covalent ionic substances. Only covalent compounds, some covalent compounds like SiO2, alumina, silicon carbide, etc. have high melting and boiling points because of their polymeric network structure. But all among the given 4, this is covalent, this is covalent, this is covalent. Only NaCl is ionic. So, ionic compounds have high melting and boiling points. Hybridization concept. Please all of you go through the hybridization given in NCERT textbook. One paragraph with structures, lone pair arrangements, hybridizations are given. Please go through, that is compulsory, chances are there to get a question from hybridization area, because one of the heart of this chemical bond topic is hybridization. Now, look at this XCF4. XCF4 undergoes sp3d2 hybridization. IF7 sp3d3, NH3 sp3, CO2 sp. So, if you match, we will get the correct option. A2, B3, C1, D4. So, option 3 is the correct answer. How to find hybridization? This is the formula. P is equals to A plus half into group number minus valency plus or minus C. There are several methods to find the hybridization. But if we use this formula, we will get both bond pairs, lone pairs. Total electron pairs will come to know. If 2 electron pairs are present, linear, 3 electron pairs are present, trigonal planar, 4 electron pairs tetrahedral, 5 electrons trigonal bipyramidal, 6 octahedral without any lone pairs. If lone pairs are present, actually orientation of electron pairs decide the geometry and shape is decided based on the lone pair electrons. Vesper theory. So, now here if you see A plus half into group number minus valency plus or minus E. For example, I will explain one XeOF4. If I take this example, now the central atom here is single atom, bigger atom is the central atom. Here this is single atom, this is single atom, bigger atom is the central atom. So, xenon, how many atoms are attached to xenon? 4 fluorines, 1 oxygen, total 5 atoms are attached, plus half into group number, xenon belongs to 0 group, 8th group, minus valency, here the valency of xenon, you see oxygen is 1 oxygen is attached, 1 oxygen means it satisfies 2 valencies plus 4 fluorines, 2 plus 4, 6. So, this is 6. It does not carry any charge, neither positive charge is present nor negative charge. Hence, this plus or minus, this is nothing but charge. Charge is not there in the given formula. So, we can ignore it. So, this becomes 5 plus 2 by 2, 1 means 6 electron pairs, 5 bond pairs. This indicates the bond pairs and this one indicate lone pair. 5 bond pairs, 1 lone pair, total 6 electron pairs. Actually, if all 6 are bond pairs, then the shape is octahedral. So, this is the shape of the molecule. Xenon at the center. If all 6 are bond pairs, octahedral molecule like this. here also one fluorine, down one also one fluorine, then regular geometry. But here one oxygen is there, oxygen double bond, and one orbital has lone pair electrons, because one lone pair we got na. So, this is having square pyramidal structure. So, XeOF4. Suppose if you take ClO3 minus, negative charge is present na. So, here number of atoms attached 3 and A is equals to 3 plus half into group number of chlorine 7, valency here see 3 oxygens are there, each oxygen will satisfy 2 valencies. So, 3 2s are 6, negative charge is present, so add 1. Suppose if it has H3O plus, when positive charge is present, you take minus. So, plus or minus E charge, if plus charge is there, minus, if minus is present, add 1. So, here the electron pairs 3 plus 8 minus 6, 2 by 2, 1. So, it has 4 electron pairs. Whenever 4 electron pairs are present, molecule has tetrahedral structure, but here 3 bond pairs, 1 lone pair. So, it has trigonal pyramidal structure. Last time just pyramidal is given, trigonal pyramidal is given. When both options are there, you have to choose trigonal pyramidal. Next. Ratio of hybrid and unhybrid orbitals taking part in the bond formation of ethylene. Ethylene is CH2 molecule. Bond pairs taking hybrid and unhybrid orbitals. Here carbon undergoes sp2 hybridization. Even this carbon is undergoing sp2 because double bond is there. Whenever sp2 hybridization takes place, 3 hybrid orbitals are formed for each carbon. So, 3 plus 3, 6 hybrid orbitals. Number of hybrid orbitals 6. A triple bond is present sp, double bond is present sp2, single bond is present sp3. Here 2 orbitals, here sp3, sp2 has 3, sp3 4 orbitals. So, sp2 3 plus 3 6. Now, pi bond hybrid pure orbitals. Pure orbitals means unhybrid orbitals. Those which do not take part in hybridization are called pure. Always hydrogens are considered to be pure orbital. Single atom atomic orbitals will take part in hybridization. Number of pi bonds for pure orbital calculation, pure orbitals is equals to number of pi bonds into 2 plus number of hydrogen atoms. Now, look at this number of pi bonds, only one pi bond is present here. So, into 2, 2, number of pi bonds into 2. So, 2 plus 2, 4 hydrogens are present. So, 6, pure orbitals 6. So, ratio is 1:1 ratio. Generally, benzene compound is given in our book. Several times we have done. For benzene, 3 hybrid orbitals, 2 pure orbitals. Ratio of hybrid and pure orbitals. Next one. Which of the following pair is isostructural? See, same shape and hybridization he is asking. Same shape and hybridization means, here directly I am explaining because several questions are there. BF4, NH4 plus. BF4, just now I told hybridization A plus half into group number minus valency plus or minus E formula. Here central atom boron, 4 fluorines are attached plus half into group number of boron is third group. Actually 13th group will take valence electrons 1 plus valency here 4 because 4 fluorines are attached. Can you see minus charge is present, so plus 1. So, 4 minus 4 0, 4 plus 0, 4 bond pairs, 0 lone pairs, no lone pairs are there. When 4 bond pairs are there, 4 electron pairs, all are bond pairs, then regular geometry tetrahedral. Coming to hybridization is sp3, 4 bond pairs, regular geometry, that is tetrahedral. Now, see NH4 plus, in NH4 plus number of atoms attached to hydrogens 4 plus half into nitrogen is a 15th group element. So, why 5 valence electrons minus number of hydrogens attached to 4. See the charge there, plus charge. So, minus 1. So, this is equals to again 4 plus 0. 4 pairs are 4 electron pairs means hybridization sp3. 4 bond pairs, 0 lone pair, 4 bond pairs, 0 lone pairs. So, both of them have same hybridization, same structure. So, isostructural. Next, the group having triangular planar structure, triangular planar or trigonal planar structure. We will select this one, triangular trigonal planar, CO3 2 minus. If you calculate sp2 hybridization, NO3 sp2, SO3 sp2, all of them have same structure, same hybridization. So, they are all trigonal planar structure species. Next, in PCl5, they are frequently asking this question. In PCl5, all PCl bonds are not identical, correct. Why all PCl bonds are not identical means, here PCl5 trigonal planar structure, 3 Cls are arranged in equilateral triangle and the remaining 2 chlorine atoms are arranged above the plane, below the plane. So, these 2 chlorines are called axial chlorines and these are called equatorial, 3 equatorial, 2 axial. 2 axial PCl bonds are longer because they experience more repulsions. That is why all bonds are not identical in PCl5. Hence, PCl5 has dipole moment. If all bonds are identical, the trigonal planar 120 bond angle dipole moment gets cancelled. These 2 are linear 180, symmetrical linear planar molecules have 0 dipole, then that will get cancelled. But because of these 2 axial bonds are longer, bond moments are not cancelled, hence dipole moment is there for PCl5. I explained even dipole moment factor here. The order of bond length of oxygen OO bond in O2, O3, H2, O2. This is also related to bond parameters. O2, oxygen, a double bond is present. O3 molecule, O3 a resonance hybrid of 2 structures, one day-to bond, one normal bond, and we can write a resonating structure for ozone like this. Because of resonance, neither it is equal to single bond length. Single bond length is 1.48, double bond length is 1.21. It is neither equal to single bond nor equal to double bond. 1.28 is the bond length of ozone molecule, and O double bond is 1.21 angstroms. And if you take H2O2, H2O2 has open book structure. Suppose if you take this structure O bond, here it is a single bond, na? So 1.48 approximately. So, if you see these structures, now if you see all the structures, OO bond length, highest is single bonded one, that is hydrogen peroxide. So, H2O2 is having high bond length when compared to now if you just a minute. Now if you take this H2O2, the bond length in H2O2 is H2O2 greater than O3 greater than O2, because here 1.48, here 1.28 angstroms because of resonance, here 1.21 angstroms. So, bond length is more, order of bond length H2O2. One more very important question mark, look at this all of you. if you take this hydrogen peroxide, it has open book structure. Here it has both polar and non-polar bonds. Between two oxygen atoms there is a non-polar bond. Between O and H there is a polar bond. As they differ in electronegativities, we call it as polar. This is non-polar. The molecule which contains both polar and non-polar bonds means hydrogen peroxide. S2Cl2. S2Cl2 is also having same polar and non-polar. Such examples also they will ask you. Polar means differ in electronegativities, non-polar means no difference in electronegativity. Next, the correct order of increasing CO bond length, similar question. CO bond length, if you take C triple bond O, the bond order is equals to 3. C double bond O, CO2 molecule, here we have 2 double bonds. CO3 2 minus, CO3 2 minus has 1 double bond, 2 single bonds. So, if you take all these, bond order is 3, bond order is 2, bond order. How to calculate bond order for such molecules means number of bonds between identical atoms. Carbon forms 1, 2, 3, 4, 4 bonds. Number of resonating structures, up to 20 electron species will take molecular orbital theory for explaining bond orders, like up to neon, Ne2, 20 electron species ki molecular orbital theory. And one more important point, molecular orbital theory is exclusively used for explaining paramagnetic nature of oxygen, that is meant to explain paramagnetic nature of oxygen only proposed. Now other species, if they have more electrons, in that case we calculate bond order by this phenomena. Calculate number of bonds between identical species. Number of bonds between identical species is 4 by total number of resonating structures. For these 3 resonating structures are there. So, we will take 1.33. So, if you compare the bond orders, higher the bond order, lesser is the bond length. So, we can say CO3 is having higher bond length when compared to C. So, correct order of increasing bond length, CO less bond length. So, this is the correct option. Next one, the resonance hybrid of nitrate ion. This is also one of the important question. Nitrate ion, it has 1 double bond, 1 single bond with negative charge and 1 dative bond. So, total bonds are 4. Now, if you see this molecule, here how many charges are there? 1 negative charge is present. That 1 negative charge is shared by 3 electronegative oxygen atoms. So, 1 by 3. So, each oxygen gets minus 1 by 3. So, option 3 is the correct one. And one more question we can expect on this is number of bond pairs and lone pairs. Suppose if you take this structure, here already 4 bond pairs are there for nitrogen. Nitrogen does not have any lone pairs. So, lone pairs are 0 for nitrogen. In NO3, number of lone pairs on nitrogen means 0. Bond pairs, if you consider, 4 bond pairs are there. Similarly, if they ask number of lone pairs in the total molecule, then you have to consider this. Now, look at this, 3 plus 3, 6 plus 2, 8. 8 lone pair electrons are present. Lone pairs are 8 pairs. No lone pairs on this molecule. Same question is there in the next one slide. See this NO3 minus ion, number of bond pairs 4. Lone pairs of electrons are present. Actually, lone pairs not present on nitrogen, but oxygen atoms, if you consider, 8 pairs are there. Last question. Formal charge PO4 3 minus. If you take this molecule, PO4 3 minus, 4 oxygens are there, number of bonds are 3. So, 3 oxygens you put a negative charge with a single bonds, and remaining oxygen double bond because it does not carry any charge. So, whenever they give formula like this, PO4 3 minus, number of charges 3 negative charges shared by 4 oxygens. So, its formal charge is minus 3 by 4. Total oxygens 4 sharing 3 negative charges because of resonance 3 by 4. And bond order, if you consider, bond order is number of bonds between identical atoms 5, 2 plus 3, Total resonating structures 4. So, answer is 1.25. So, this is formal charge, this is bond order for PO4 3 minus. Okay students, I could able to do this much, and in next class we will finish the other things. Thank you.
Yeah. Good morning, my dear students. I am sure you are preparing well for the NEET entrance examination going to be conducted next Sunday. Coming to the point, from our side, one of the important topic for the entrance examination by name work power energy will be having a quick and revision of some of the main points and some of the important questions. This is SVS physics trying to do some questions that would possibly come in the entrance examination. I am sure you will focus on the topic and understand well and do well finally. Okay. The topic is work power energy. Right here you can see that suppose there is a big object, it has to be moved from one point to the other point towards the left. You can see a gentleman applying a force there, causing some displacement so that the body moves from one point to the other point. So, in order that a body has to move, you will be applying the force there, and you have to do some work on it for it to be getting displaced. In order to do work, you need to have energy. Okay. And in order to do the work, you have to spend the energy, and for spending the energy, you require power there. So, this is the basic topic we are doing there, work, power, energy. So, our focus will be on these three terms and their simple and important application. Okay. Suppose this is a body of mass m. It is kept on a horizontal surface. On this body, you are applying the force F like this. You are applying the force F like this, so the body undergoes some displacement. Whenever a force is applied on a body and the body undergoes some displacement, some work is said to be done. So, work is said to be done when a force acting on a body causes some displacement. Now comes two different cases there. Case number one, the force acting on the body is constant, or sometimes you may be applying variable force. Suppose you want to push a car there which has got broken down, then you will be applying lot of force initially, and gradually you may be applying a lesser force there. So, force may be constant or force may be variable. Okay. Now we are dealing with the point number one there, the force acting on the body remaining constant throughout its motion there. Okay. Now, the heading itself you can see work done by constant force. Okay, work done by force F is equal to Fd cos theta, where F is the magnitude of the force applied, D is the displacement, theta is the angle between force and displacement. Work done by the force is Fd cos theta. It can be written as F dot D. You must be knowing that A dot B is nothing but AB cos theta. So, F dot D is Fd cos theta. So, work done by the force F is Fd cos theta, F dot D, nothing but the scalar product or dot product of F and D. But you have to remember one point, when you apply this particular formula there, this formula is applicable only and only when the force acting on the body is constant, both in magnitude as well as direction. Okay, its magnitude should be constant, and the way it is directed should always be constant. Okay, that's a point number one. So by now you have understood that work done by the force F is Fd cos theta F dot d to be used there. You must have some basic idea about the scalar product there. Yes, this particular topic I am dealing today involves a good number of topics in mechanics. It requires vectors, it requires kinematics, it requires Newton's laws of motion and other things there. Pay attention. So how to calculate F dot d? Generally the force vector we write as Fxi plus Fij plus Fzk. Displacement vector is dxi plus dyj plus dzk. From these things work done is F dot d. How to find F dot d means Fx dx plus Fy dy plus Fz dz. Leaving ij case, I repeat again please, leaving ij case, F dot d means Fx dx plus Fy dy plus Fz dz. We will be applying that particular point a good number of times right in our discussion. Okay. We are going to do some problems based on the work done by the constant force. Okay, see here. A body moves from an initial point A of position coordinates 2, 3, 4 to a final point B of position coordinates 4, 2, 1 in 9 seconds. The body is moving from one point to other point exactly in 9 seconds. Under the action of not one force but a set of 3 forces. So it is moving under the action of 3 forces, F1 given, F2 given, F3 given. Okay, F1, F2, F3 in newtons are given. So everything is happily given in SI system. Make a note of it. Now I want to know what is the total work done by the forces on the body and what is the average power developed right in this time. Okay. Now the point number 1 that is needed is that whenever the position coordinates of the point are given there, so whenever the position coordinates are given there, so then position coordinates of the point are given, how to find the, only 1 second please. Okay. Okay then, we want pen. Just a second please. Now we will get back to the question little once again there because of the small interruption we had. Then see. So once again repeat that a body which is having the initial position 2, 3, 4 has been finally displaced to 4, 2, 1 exactly in 9 seconds under the action of 3 forces you see F1, F2, F3. Then I want to know what is the total work done and what is the average power developed. The question definitely involves 4 simple and basic points of mechanics. Point number 1, whenever the position coordinates are given there is, these are the position coordinates of a point x, y, z. So the required basics I have written here there. So whenever the coordinates of a point are given as x, y, z, its position vector is given by xi plus yj plus zk. That's the point number 1. Okay, now the initial position of this particular point is given as 2, 3, 4. So what is the initial position vector means? 2i plus 3j plus 4k. That's the first point. The final position is given as 4, 2, 1. So the final position coordinates are 4i plus 2j plus 1k. Okay. When position vectors are known, what is your next step there? You have to calculate the displacement of the body. When you know initial position and final position, in the topic by name vectors, you must be knowing that the displacement is given by, displacement is R2 minus R1. So this is the formula for displacement of the body. When you know initial position, final position, displacement is this much. So what is the displacement of the body? You have to subtract these two, R2 minus R1. So you will be subtracting this way. Now come on, tell me, if you subtract the 4i minus 2i, it comes out to be 2i, 2j minus 3j comes out to be minus j there, 2i minus 3j minus j, 1k minus 4k comes out to be minus 3k. So these are the things as far as displacement is concerned. Now the body is under the action of more than one force. If more than one force acts on a body, then we have to bother about the resultant force, net force acting on the body. What is the net force there? Once again, net force is the vectorial sum of F1, F2, F3, F1 plus F2 plus F3. So this F1, F2, F3 are given here, there, you just add them up. So when you add them up there, so F1 you know, F2 you know, F3 you know, you are adding there. 3i plus 2i plus 4i, it comes out to be 9i there, this is 9i. This 4j minus 4j get cancelled there, so this is 0j, and 6k minus 3k comes out to be 3k, so this is a force in Newton. So now we know the net force as well as the displacement. Okay, now I am writing the net force acting on the body, that is 9i plus 0j plus 3k Newton. What is the displacement of the body there? So displacement is 2i minus 1j, this is minus j, I am writing minus 1j, minus 3k, this is in meters. What is the formula for work done? Work done is F dot d. When force and displacement you know vectorially in terms of ijk, then work done is F dot d. Okay, what is F dot d means? Already we know, in the previous slide we have seen that work done F dot d is fx dx plus fy dy plus fz dz. So coming to this point there, what is F dot d means? You have to multiply these two, 9 into 2, 18, this comes out to be 0, this is minus 9. So the net work done is equal to 9 joules. So that's the answer for the first part of the question. The total work done is 9 joules exactly. I want to know what is the average power. Average power is total work done divided by total time. What is the total work done? 9 joules. And in what time means? Given the question, exactly this is undergoing the displacement in a time interval of 9 seconds there. So this is the time interval of 9 seconds given. So this is 9 seconds. So this comes out to be 1 watt there. So average power developed. The formula for average power is total work done by total time. You know the total work. You know the corresponding total time. This comes out to be 1 watt. Okay. Now let us see the relevant recent entrance questions that have come in the NEET there. So if you do the previous question, you can just easily tackle these things. A uniform force of 3i plus j Newton acts on a particle of mass 2 kilogram, and the particle is displaced from the initial position 2i plus k to a final position like this. What is the work done by the force there? You can see that this is a NEET 2017 question. Okay. A uniform force of 3i plus j newtons there. That means the force acting on the particle, here I am writing there, this comes out to be the uniform force of 3i plus j newtons. So this is the force acting on the body, 3i plus j, that means 1j. And there is no k term there, we can write 0k Newton. This is the force acting on the particle. This force displacing the particle from where to where? The initial position 2i plus k. So I am writing 2i plus, there is no j term, 0j plus 1k. This is the initial position 2i plus k meter to a final position 4i plus 3j minus 1k meter. Okay, I want to know what is the work done by the force. Even though the question is simple there, to avoid unnecessary mistakes under the exam tension conditions there, better write 0j there. So the initial position is given as 2i plus k, j is missing, so you please do write 0j from your end. So R1 you know, R2 you know. When you know the initial position, final position, you have to calculate the displacement R2 minus R1. What it comes out to be? 4i minus 2i, it comes out to be 2i plus this is 3j minus 1k minus of 1k, that comes out to be minus 2k, so many meters. This is the displacement. So here I am writing the displacement of the particle. The particle undergoes a displacement of 2i plus 3j minus 2k meter. What is the work done there? Work done is F dot d. F dot d means, already we have seen, this is fx dx, that is 6, plus fy dy 3, and fz dz 0. 6 plus 3 comes out to be a 9 joules there. So this comes out to be 9 joules. So that's the answer for one of the recent entrances. See here. Okay, Is it that in 2017, pre-corona, they asked the easy questions, aren't they? Post-corona questions are much easier there. Please believe, please believe. Okay, you can see 2023 bit, last year's NEET entrance. A particle moves with a velocity 5I minus 3j plus 6k meter per second, okay, horizontally under the action of constant force of this much. What is the instantaneous power developed there? So the point number 1, a particle is moving under the action of this constant force. You please see that the force is constant. How much constant means? 10I plus 10j plus 20k. Once again, the force magnitude is not given. Force is being given vectorially in terms of ijk. Make a note of that point. Okay, force is not given 10 Newton, 20 Newton like this. It is given in terms of ijk. So 10I plus 10j plus 20k Newton. Okay, now under the action of this force, the particle happens to move with this much velocity there. So 5I minus 3j plus 6k meter per second. Okay, I want to know what is the power there. Okay, now power is equal to, just now we know that power is basically work by time. Work is the dot product of force and displacement F dot d divided by time. Work is F dot d by time. Now you know that this is F dot. What is displacement by time comes out to be? Okay, displacement by time is velocity. So this is the small simple formula of power in terms of vector F and vector V there. So once again, power is work by time, work is force dot displacement divided by t. So force dot displacement by time means velocity. So this is a formula we are using here. Okay, how this formula is arrived means we have a small idea. So power is F dot V. Once again, to do this particular dot product there, you have to have the simple clarity about the scalar product of two vectors. So how to find F dot V means is you have to multiply these two things there. 10 into 5, 50. This comes out to be the velocity of the body is nothing but 5I minus 3j. 5I minus 3j. So 10 into 5, 50. This comes out to be minus 30 plus 20 into 6 comes out to be 120. For the last time I repeat, the velocity of the particle happens to be 5I minus 3j there, okay, plus 6k. So F dot V means 50, 10 into minus 3 minus 30, 20 into 6 120. If you happen to do 50 minus 30, 20, 20 plus 120, 140. So SI unit of power you know, watt. So the answer for the question is 140 watts. Okay, happy plus 4 marks. In a span of around 20-25 seconds in the exam hall, almost by any student there. The next question. Okay, is 2023 alone is easy and means you can see much easier question right in the NEET 2022. So this is the time not only to go through this revision program but feel confident about yourself and feel confident that exam will be easy and you can 100% crack it perfectly. Then see, the energy that will be radiated by a 100 kilowatt transmitter in 1 hour is dash. Okay, so he has given the power of the radiator there. So there is a transmitter, TV transmitter, radio transmitter or anything there that is transmitting power of 100 kilowatt and what time is given means 1 hour there. I want to know how much energy is being radiated. Okay, once again same thing, power is work by time. All of you know work energy equivalence, you know the work energy equivalence. So work done we can write in terms of energy. So power is work by time in general. Right in this aspect, so work done in terms of energy comes out to be energy being radiated divided by time. So what is the power there? He said 100 kilowatt, 100 kilowatt, that means 10 to the power of 3 watt there. That's the first point. So that kilo is 10 to the power of 3. Energy radiated we want to know by time. What is the time given in the question? Time is given as 1 hour there. So everyone in the class know 1 hour means 60 minutes there and convert minutes into seconds there. It comes to be 3600 seconds. So the time happens to be 3600. So the energy is equal to, you can say 3600 into 10 to the power of 3 into 100, 10 to the power of 5. So this is 36 into 10 to the power of 7. Everything in happy SI system. So it is 36 into 10 to the power of 7 joules. Okay, so this will be the answer for this NEET 22 question there. If you search the paper little bit properly there. Okay, out of 50 questions, at least 35 questions will be this type there, almost this type there. If you can really search with patience, without tension there, and all those questions, you should easily crack it. Then, till now we are talking about work done by a constant force. Now it is time to discuss what is the work done by a variable force. Yeah. Now, work done by variable force. Before we go to work done by variable force, first point we have to understand is, what do you mean by variable force? Okay. Then, the example of variable force is being mentioned here. Suppose a body is being displaced from this point to this point there. A body is being displaced from, 1 second please. Okay. A body is displaced from one. Sir. Okay, then pay attention. See here. What is the example of the variable force there? So, suppose a body is being displaced from one point to the other point like this. Okay, when the body is here, it will have some x coordinate there, here some other x coordinate. Suppose here it is something like 2 meters, it is something like 5 meters and so on. So, its position x keeps on changing. Okay, suppose the body is under the action of a force F given by F is equal to 3x plus 4x square. So, when the body moves, x will keep on changing. When the body is moving like this, x will keep on changing. As x changes, force will also change. That is a simple meaning of variable force. So, you see that a body is under the action of force F is 3x plus 4x square. When the body is being displaced, its x coordinate keeps on changing. As x changes, you can see this force will also change. Okay. Whenever a body is under the action of variable force, that too the force varying in x direction as well as y and even along z. So, if there is a situation of force varying in all 3 dimensions there, then in such a case, work done by the force comes out to be integral of fx dx plus integral of fy dy plus integral of fz dz. Yeah. Now, remember this point there. This particular formula like work done is equal to fd cos theta is not at all applicable for variable force. If the force is varying, no question that you can use this formula there. You have to depend upon this integration. Okay. By chance, if some students get the doubt that do they ask integration questions in NEET like exam, means plenty of times they asked. Okay. Many times they asked right in the NEET itself there in the last 12 years. Now, you will be seeing some of those questions. Before that, I want to do my standard bit first. Pay attention. Okay. Before we go to this particular work done by variable force, what are the basic requirements there? You must be good at integration. Yes. Now, what are the necessary steps of integration? Integration means not a huge integration we want. After all, if you focus on the topic for 2 to 3 minutes maximum, you can necessarily do whatever things that are required. Yes. Coming to the point, what are the basics of integration required means? Integral of x to the power of n dx comes out to be x to the power of n plus 1 by n plus 1. Integral of x to the power of n is x to the power of n plus 1 by n plus 1 plus some integral constant. Similarly, integral of x squared dx means x cubed by 3. Integral of x dx means x squared by 2. Integral of dx is x. So, these are the requirements there. So, you must be good at this particular thing there first. Okay. Now, concentrating on the question here. For a body moving along x-axis, force varies with position x, and that force is position dependent, and that force is Fx is equal to 1 plus 2x plus 3x square Newton. I want to know what is the work done by this force as it gets displaced from 1 meter to 2 meter. The body is getting displaced from 1 meter to 2 meter. What is the work done by the force? To begin with, what is the formula for work done? Okay, in this particular case, make a note that the force is variable. Force is variable, point number 1. That too, it varies only along x-axis, is Fx, it is varying along x-axis. When the force varies along x-axis there, then our formula will become like this. If this is a 3-dimensional force, this is the complete formula. If only Fx is given there, understood, other two are absent there, so work done is integral of Fx dx. So work done is a simple formula, now it becomes integral of Fx dx. What is Fx comes out to be? 1 plus 2x plus 3x square dx. Now you expand it. So this comes out to be integral of, common term of u, 1 into dx, that means integral of dx, plus integral of 2x dx, plus integral of 3x square dx, just expand it. Now integral of dx, already we know integral of dx is x. Whenever you are doing integration there, the constant term should be brought outside the integral sign. So you are bringing 2 outside, so these are 2 outside. Integral of x dx, integral of x dx is x squared by 2. Similarly, the constant 3 outside the integral sign, 3, integral of x squared dx, x cubed by 3. Now you can see 2, 2, 3, 3 cancels. Now after doing integration, the first point is that you keep the result in square brackets, So this is x in square bracket, this is x square in square bracket, this is x cube in square brackets. Now you have to write the limits. The body is getting displaced from 1 meter to 2 meter there. The body is getting displaced from 1 to 2. So you have to write the lower limit here there, upper limit here there, 1 to 2, 1 to 2, 1 to 2. Then how do you simplify it further? Now this is x varying from 1 to 2, then you have to write 2 minus 1, this is 2 minus 1. This is x square varying from 1 to 2, then you have to write the upper limit here there, 2 square minus 1 square. This is x cube varying from 1 to 2, you have to write the upper limit first, 2 cube, put minus sign and minus 1 cube. So this is the way you write it. Okay, now if you simplify it, 2 minus 1 comes out to be 1, this is 4 minus 1, 3, this is 8 minus 1, 7, so it comes out to be 7 plus 3, 10, 10 plus 1, 11, 11 joules there. This is the work done. So this is the work done by variable force. Okay, what prompts your teacher to pick up this particular question from his end means, you see this 2019 NEET question. A force F is equal to 20 plus 10y acts on a particle along the y direction where force is in Newton and the y value is in meter. What is the work done by this force when the body is getting displaced from 0 to 1? The body is being displaced from initial value of y, y1 is 0 to y2 is 1. That is the meaning of that one. Okay. Now you can see that here the force is varying along y direction there. So it comes out to be as a first step Fy. Previous question we were dealing is with Fx. So this is Fy. So Fy is equal to 20 plus 10y. When only Fy is given, what the formula for work done means? Integral of Fy dy. There is no Fx, there is no Fz, forget about it. So work done is integral of Fy dy. So Fy comes out to be 20 plus 10y into dy. Now you have to just expand the terms as we did in the earlier question. So this is integral of 20 dy plus integral of 10y dy. If you expand it, integral of 20 dy, integral of 10y dy. Whenever you are doing integration, bring the constant terms outside. So 20 into integral of dy plus 10 into integral of y dy. That basics of integration was in the previous slide, and if you just use it, 20 into integral of dy comes out to be y plus 10 into integral of y dy comes out to be y squared by 2. If you do it, this is 20 into y, this is 5 times y square. As I told just now, after doing integration, the result you have to keep in square bracket. Yeah. Now you have to write the limits there. What are the limits means? You know that this value is y1 is 0 to y2 is equal to 1. y1 is 0 to y2 is 1. Here also it is y1 is 0 to y2 is equal to 1, as you see the limits. How do you continue further? 20. This is y varying between 0 to 1. First you have to write the upper limit there. So 1 minus 0. Y you have to put 1, 0 plus 5. This is y square varying between 0 to 1. So this is 5 into this 1 you have to write 1 square, because this is y square, na? 1 square minus 0 square. Rest of the things I need not explain. So this comes out to be 20 plus 5. So the final answer comes out to be 25 joules. This answer for that NEET 2019 bit. Yeah. The next concept we are going to concentrate on is how to calculate work done by the other methods there. So we have done these things. We have seen when force and displacement are given, how to calculate work done. That too, when the force is variable, how to calculate work done. We have seen those points. Now coming to the next point there, calculation of work done when force displacement graph is given. When force displacement graph is given. Suppose there is a force displacement graph. Whenever there is a force displacement graph there, then area enclosed by this force displacement graph with respect to displacement axis will give you work done. Area enclosed by FD graph, force displacement graph, that too with this displacement axis will give you the work done. Okay. Now, as per work energy theorem there, the total work done by all the forces acting on the body happens to be changing kinetic energy. Work done by each and every force that is acting on the body is equal to changing kinetic energy. What do you mean by changing kinetic energy? Ke final minus Ke initial, Ke2 minus Ke1. You know the formula for kinetic energy, half m V2 square minus half m V1 square. When you take half m common, half m into V2 square minus V1 square. Yeah. So these are the necessary points for us to proceed with some valuable questions hereafter. So point number 1, just I revise again. Whenever FD graph is given, within crore of a second you have to make up your mind in the exam hall. What for the graph is given means the area enclosed by the graph with respect to displacement axis will give you work done, point number 1. And how to calculate work done and when kinetic energies or velocities are given means work done is changing kinetic energy or half into m into V2 square minus V1 square. The next point, how to calculate velocity, that's the next step there. So when position time relations are given, when position time relation is given there, in kinematics you know that velocity v is equal to dx by dt. Is this work power energy involves good mechanics chapters there. So from kinematics we have to recollect that when position time graph is given, v is equal to dx by dt. So with the clarity about these basics there, you can just do any question almost on your own. Acha, now in this particular topic there, you need some differentiation there. Yeah, earlier we were discussing about integration and already you have seen. I picked up only one question for you to show that integration is necessary. Actually there are another 4 questions there under the heading of NEET which were using integration principles in work power energy. I have shown you only one bit. Now there are a lot of questions right in NEET entrance based on the involvement of differentiation, many. Okay. Then so what the necessary basics of differentiation we require means, once again only 3 minutes if you concentrate. So differentiation of 2 to the power of t to the power of n by t, differentiation of t to the power of n with respect to t comes out to be n into t to the power of n minus 1. So based on that we can prove that differentiation of t cube with respect to t is 3t square, differentiation of t square with respect to t 2t, differentiation of t with respect to t 1, and differentiation of a pure number without any t involved, differentiation of a constant with respect to t is 0. So those are the necessary points. Where from we get all these things from this fundamental point there, as you know. Okay. Now coming to the question. For a 2 kilogram body moving along x-axis, there is a 2 kilogram body moving along x-axis, position and time are related by 2t is equal to root x minus 1. The position x and time t are related by this particular formula. Okay, everything is in SI system. I want to know what is the net work done by all forces in the first 4 seconds of its motion. This wording is little important keyword. What is the work done by all forces in first 4 seconds of its motion? So there's a question here. Now listen. First of all, what is the position and time relation given there? So 2t is given as root x minus 1. So 2t is root x minus 1. Now what we do is that you express x in terms of t. In not 99% of questions, 100% of questions, you have to express x in terms of t. Here intentionally t is written in terms of x there, you have to express x in terms of t. 2t is equal to root x minus 1. You bring this term this side. Okay, root x is equal to 2t plus 1. Now, I do not want root x, I want x, I want position x. So, how to calculate the position x means square it. X is equal to 2t plus 1 whole square. Now, you know 2t plus 1 whole square means a plus b whole square, and remember a square plus b square plus 2ab. So, 2t plus 1 whole square means 4t square plus 1 plus 4t. So, 2t whole square 4t square, 1 square 1, 2ab, 2 into 2t 4t. So, x we got it as 4t square plus 1 plus 4t. Why we are doing like this? Why we want x on one side? Why we want x on one side? That is the point. Why means by now we have understood by looking at the next step there. From position x, you have to calculate velocity. How do you calculate velocity? V is equal to dx by dt. V is equal to dx by dt. So, you need to have x in terms of t. So, in the entrance exam, you can have two type of versions in the question. In some questions, they may give x directly in terms of t, as you see in one of the previous NEET question, and in some questions, they give t in terms of root x. Once again, that way also they asked already. So, first we are doing this slightly more standard model. Okay, so V is equal to dx by dt. How do you differentiate it? V is equal to dx by dt means 4 differentiation of t square. Just now we have seen differentiation of t square with respect to t is 2t plus differentiation of a pure number. Differentiation of a pure number or constant number is 0 plus 4 differentiation of t. Differentiation of t with respect to t is 1. Differentiation of t with respect to t is 1. So, when you know x is this one, so velocity v comes out to be dx by dt. So, you have to do the differentiation based on that simple knowledge. So, if you just see it, here the velocity comes out to be 8t plus 4. So, the velocity in terms of t comes out to be 8t plus 4. So, velocity is a time dependent. As time varies, its velocity varies. How does it vary means v is equal to 8t plus 4. Okay. Now, what are the time duration we are interested about? If you read the question, what is the net work done by all forces in first 4 seconds? Yeah, you have to understand that point. First 4 seconds means from the starting time till 4 seconds, first 4 seconds. So, starting time happens to be 0, first 4 seconds, starting time 0, the end time happens to be 4 seconds. So, you want to know work done by all forces in the duration of t1 is 0 to t2 is 4. Now, already we got velocity as 8t plus 4. Now, at t1 is 0, I want to know what is the velocity. At t1 is 0, what is the velocity means 8 into 0 plus 4. So, this comes to be 4 meter per second. What the velocity at t is 4 seconds, put here there 8 into 4 plus 4 there, 32 plus 4 comes out to be 36 meter per second, 36 meter per second. So, you know the initial velocity, you know final velocity. What is the next step there? I want to know what is the total work done. So, what is the total work done by all forces means changing kinetic energy, standard version of work energy theorem. So, the net work done by all forces is changing kinetic energy. Changing kinetic energy means K2 minus K1 or half m into V2 square minus V1 square, half. What is the mass of the body given? Here the mass of the body is given as 2 kgs. So, half into 2 into V2 square minus V1 square, 36 square minus 4 square, 2 can be cancelled. Better not do 36 square as 36 into 36. Of course, you know it. Better not do it. This is 36 square minus 4 square now. This is like a square minus b square. So, everyone knows a square minus b square is a plus b into a minus b. 36 square minus 4 square means 36 plus 4 into 36 minus 4. So, 36 plus 4 comes out to be 40. 36 minus 4 is 32. If you do simplification there, it comes out to be 1280 joules. This is the answer for work done. SI unit of work is joules, 1280 joules. That is the answer for the question. Okay. Generally, examiners are highly interested about application of law of conservation of energy. At least one such question minimally appear in every entrance examination. So, this is a question dealing with this particular one. This question is a combination of oblique projectile motion of kinematics plus work power energy. Okay. A body is projected obliquely from the top of a tower of height 25 meters. So, this is a tower of height 25 meters. A body is projected obliquely from the top of a tower of height 25 meters. with a velocity 72 km per hour. So the velocity of projection is given as 72 km per hour at an angle of 60 degrees with the horizontal. All of you know, when you throw the body obliquely, the body will all the way go like this and strike the ground there. I want to know, with what velocity does it strike the ground? With what velocity will it strike? Yeah, when you throw the body has to fall on the ground. Because of gravity, it will come and hit the ground. Now. So with what velocity will it be striking? Listen carefully. Right in this particular question, intentionally some surplus data is given there, and there's a thing the examiners definitely do in the exam. They give some extra information. Okay, you have to just ignore that data there. By now you should have made up your mind what is the thing that is not required in the question. Okay, so and one more thing is about units conversion. In every entrance examination, a good number of questions will definitely twist you under the heading of units there. Okay, see here. So a body is projected obliquely from the ground, from the top of it hour of height 25 meters, Pakka SI system, very happy, with a velocity of 72 km per hour. So here the velocity of projection u is given as 72 km per hour. So this is the velocity right at the point A there. So this velocity at point A is kilometer per hour is not SI system. Okay, convert into the SI units there, 5 by 18 meter per second. 1 kilometer per hour, 5 by 18 meter per second, it comes out to be 20 meter per second. So the velocity of projection of the body is 20. So the body is being projected like this, the body will strike the ground. With what velocity will it strike? Okay, what are the necessary concepts there? Point number 1. The body is moving under the action of gravitational force. Only one force acts on the body. It will pull the body down there. The body moves under the action of only gravitational force. You know that gravitational force is a conservative force. When the body moves under the influence of only conservative force, the total mechanical energy of the system will remain constant. So body moves under the gravity, and understood that there is no friction, and we can use the law of conservation of energy when the body moves under the action of only conservative forces. What does the law of conservation of mechanical energy says? Total mechanical energy at every point during the course of its motion will remain same. So total mechanical energy at A is equal to total mechanical energy at B. Total mechanical energy at A means potential energy plus kinetic energy at A. Total mechanical energy at B, potential energy plus kinetic energy at B. What is the formula for potential energy? mg into height of A, kinetic energy at A, half mva square. Similarly, mghb, half mvb square. Now, what is the next step hereafter? The term m gets cancelled throughout. That's the first thing you have to do. Okay, now you have to look at the value of g. Sometimes they give g as 10. If they don't give g, you know that you have to take it as 9.8. But here it is given as 10. Okay, g is 10. What is the height of point A there? 25 meters. Is the body is projected from this point at a height of 25 meters plus half. With what velocity is projected means 20 meters there. So 20 square. G is 10. What is the height of point B? So all of you know that this point is the reference point there. So the ground is the reference one. The height of point B is 0. So 10 into 0 plus half VB square. 25 into 10, 250. 400 by 2, this is 200, is equal to half VB square. This comes out to be 450. 450 is VB square by 2, and VB square is equal to 900. And if you further simplify, VB is root 900, it comes to be 30 meter per second. Happily ended arithmetic. So this is 30 meter per second. But what you have to notice there, you did not use a part of the information given in the question. What is that means? This is 60 degrees not playing a role anywhere. There is a surplus data, you don't require it. Okay, there is a small point right in the question. The next bit. Here you can see that we have got force displacement graph. So we have a force displacement graph. For a body of mass 2 kg moving along x-axis, its initial velocity at x1 is 0, and whenever it is starting right from the origin there. So right at that initial position x1 is 0, its initial velocity v1 is equal to root 13 meter per second. Find its velocity at x2 is equal to 10 meter. At x2 is 10 meter. What is this velocity? That too, the answer is being asked in terms of kilometer per hour. Very silently, that KMP wording is sitting right here in the question there. You have to notice it. Yes, you will be under tension there. okay, but even then with controlling yourself, you have to see the key wordings in the question. You want the answer in kilometer per hour. Okay, force varies with displacement like this. So once again force displacement graph is given and you want to calculate the velocity at 10 meters there. Okay, so the initial position x1 is 0 there. At x1 is 0, its velocity is equal to root 13 meter per second, point number 1. Now the final position x2 is 10 meters and at 10 meters there, what is the velocity? It is a very good question involving two combined concepts of work power energy. One thing is area under force displacement graph will give you work done. Next thing is work done is a changing kinetic energy. Both the things you have to combine to get the answer for this question. Okay, whenever the FT graph is given, you calculate the area. Okay, first this particular graph will enclose some area here, it will enclose some area here, it will enclose some area here. What are the three areas it is enclosing? A1 is the area of this first figure there. So A1 is the area of this first figure. This area we are calculating first. So what is this area here? It comes out to be means the first one is a triangle. A1 is the area of the triangle, half into base into height, half into what the base comes out to be 2. What the height means 8. So it comes out to be 8 joule. Okay, this is the first area there. It comes out to be 8 joule because area will give you the work done. What is the second area? Second area happens to be this particular area there, this red colored one. This area is nothing but the area of a rectangle. Area of a rectangle comes out to be length into breadth. What is the length there? All of you know this happens to be the length term. This is the length term. What is this length term means? This is 2, this is 4. So 4 minus 2, this comes out to be 2 meters. So the length is 2 there. So here the length comes out to be 2. What is the breadth means? 8. 2 into 8. So this is 16 joules. Area will give you work done. So final area in terms of work, joules. What is the next area there? The next area happens to be area of this designer one, this one. What is the area of this one means? This area 100% is a rectangular area. Area of the rectangle, length into breadth. So what it comes out to be means, what is the length there? This is 4, this is 10, 10 minus 4. So this comes out to be 6 into breadth. If breadth comes out to be minus 2, that's the main point you have to make a note there. This displacement is in this way. This is positive displacement means this comes out to be negative displacement. So we have to write minus 2. So this comes out to be 6 into minus 2, minus 12 joules. Okay, we have calculated 3 areas there. 3 areas means the net work done is total area A1 plus A2 plus A3. If you sum them up, so it comes out to be 8 plus 16 minus 12. So this is 24 minus 12 there. Okay, it comes out to be 12 joules. It comes out to be 12. Now I want to know what is the final velocity. Work energy theorem says that net work done is changing kinetic energy K2 minus K1 half mV2 square minus V1 square. We have already calculated net work done. Net work done is 12. This 12 is equal to half into mass. What the mass of the body means 2 into V2 square is, we don't know V2, minus V1 square. This comes out to be 13. V1 is root 13, V1 square 13. 2 can be cancelled. Minus 13 comes this side as plus 13 there. So 13 plus 12. So we can say that 12 plus 13. 12 plus 13 is equal to V2 square. So V2 square happens to be 25. So V2 is equal to 5 meter per second. Okay, there will be a tempting answer of 5 right in the option 1. I repeat again, there will be a tempting answer of 5 right in the option 1. We should not get carried away that way. Now you want the answer in terms of kilometer per hour. Whatever answer we got, this answer in meter per second there, but we want the answer in kilometer per hour. How do you convert this into kilometer per hour means everyone knows 1 kilometer per hour comes out to be 5 by 18 meter per second. So what does it mean? 1 meter per second comes out to be, if you cross multiply, 18 by 5 kilometer per hour. Of course you know it. So you are converting meter per second into kilometer per hour. So you multiply with 18 by 5 kilometer per hour. So the answer comes out to be 18 kilometer per hour. That will be the answer for the question. So, while reading the question only, if possible, and make it possible, that is the inner meaning there, underline the key wordings. Don't read the question hurriedly, understand it. So, after doing this much work there, okay, you should not go wrong anywhere with the units conversions. So, read the question properly and then you end up in the correct way. I am sure these classes from our side, the humble attempt we are doing is useful to you there. So, I am sure you work hard and excel a lot. All the best. Bye bye everyone. Okay, then.